Darwin, please switch on your cam, switch on your audio. And Carlos Montes, you already have the rights as well, so you can try that out. Brennan, thank you very much for this presentation. There are also more questions coming in still. One person is asking about open source and inner source. It's a new topic for some of the people. Yeah, if you want to answer that, you can definitely also type it in to the shared notes.
I'll follow up on, I'll go through the notes and respond to everyone that's left and post a couple of links that we had.
Okay, awesome. Thank you very much. Darwin, then we come to the next session, which is the live technical session. And I see Carlos, you're nearly all set. You still need to hit the icon for the earphones twice and then activate the microphone. Yeah. Just the microphone option. And I see Darwin, you've succeeded with that already. We can't hear you yet. So, and Carlos, still need to activate your microphone as well, like you're muted. Yes, can you try, please?
Hello, can you hear me?
Okay, yeah. Carlos, we can hear you. Darwin, we can't hear you yet. I learned that a few days ago, some browser. Darwin, are you all set? Yes, now all cool.
Yep, all right, bravo.
Okay,
Nice.
Perfect. So you're gonna guys doing web sharing, or do you also have slides? How will you share do your session?
I think mostly we will be sharing the screen share.
Yeah,
Carlos.
Yeah, first we will start sharing, and then I'll share my screen for the demo.
Yep.
Okay, cool. So Carlos, then I make you presenter.
Okay.
And yeah, you see the 4 buttons in the middle on the right hand side is screen share. If you want to upload a PDF later, also there are other options also to upload it to the server, but I think you will stay with screen share mostly now, right?
Yeah, I can do screen share. Let me. Screen. And
okay, perfect. Cool. Then we can get started with the next session. So next session is all about testing. It's about building open source plugins for enterprise scale device testing with OpenTap. And we have the speakers here. It's Darwin Subramaniam, R&D engineer at Keysight Technologies. Darwin has joined the Keysight Pathwave Acceleration team as a software engineer and is there already for more than 2 years now, but he has already 5 years experience in software development. The focus of Darwin is software development around the key area of OpenTap, and he's a part of the TAP support and trainers of OpenTap team, conducts training for the Pathwave Acceleration team across different regions, and he has a bachelor in mechatronic from the University of Applied Science Niederrhein in Germany, and also his hobbies, apart from his job, is badminton and still tinkering with DIY stuff. So still a bit related to your job, actually. Can't leave it apart too much, like also tinkering still. And
Yes.
about Carlos. Carlos is a test automation solution engineer at Keysight Technologies, and has experience on high volume manufacturing, R&D and service, and is an expert in development of hardware and software test solution for automotive, mobile and infotainment. I guess that's also what you like, good cars and entertainment. So I can see the connection here. Great to have you guys here on board, and thank you very much for sharing your knowledge. Please go ahead. It's all yours. Thank you.
okay. So I'll start by sharing the agenda. So we have a few points for today, so I'll try to go quick through this, but we will do first a recap from last year. I guess everybody can download slides after we are done. So the part of the demo is also included in the slides. So let me start by doing the recap from last year. So we, like Brandon mentioned, last year we were at this summit, and you can find the presentations from last year. But basically, what we implemented last year was a Python OpenTap plugin for PS Lab, where we built an oscilloscope and a generator instrument driver. We also developed some test steps to generate the waveforms and also to measure the RMS voltage of the PS Lab module. Then we built a test sequence using the editor, which is similar to what we will be using today, and ran it. And at the end, we visualize the results using the results viewer, which is part of the editor of the package. We will also show today an alternative for visualizing results. So what are implementing today? Well, last year, in contrast, we were using Python as OpenTap supports. It also supports C#. So we will be building the plugin in C#. We will implement a new instrument driver, which is using Modbus as the communication interface. We will also implement a couple of test steps to access data from an instrument, and then we will publish those results. Then we will use the result viewer to visualize those results, and we will provide you a basic idea on how the component settings and the CLI action will extend the OpenTap platform. And finally, we will visualize the results using Plotly, another open source application. So let me start really quick by describing what Modbus is. So Modbus is a data communications protocol. It was originally developed or published by Modicon, and it's extensively used in PLCs. These are widely used in the industry. It also provides a way of communicating with environmental chambers, which is what we're going to be simulating today. But like I mentioned, it's also used in PLCs. Modbus is it's openly published. It's royalty free. That's why a lot of people use it in the industry. And there are several ways to communicate using Modbus. One is serial communication, either RS-232 or RS-485. But there's also TCP or UDP transport layer. So just a quick example. This is one of the environmental chambers that we have worked with. This is from a company called CSC, but in here you can see the products are soaked in it, and there's a need to automate the temperature profiles, temperature and humidity profiles that these devices under test will be exposed. So that's what we will be working on with today. These are examples of different controllers. Like I mentioned, there are several of them. We will be focusing on only one for today. This is another example of where Modbus is used. So in conveyors, using PLCs, that's how, I mean, in the industry, the conveyors are being controlled, but also the sensors are part of this system, and the count of parts that are coming through the conveyor, those can be available from the PLC itself. So that's also another area where you can find Modbus is used. So really quick, what are the object types that Modbus uses? So there are basically 4 different types. 2 of them are 1-bit size. The other 2 are 16 bits size. And some of them are read and write. Some of them are read only. For our example today, we will be focusing on the holding registers. So these PLCs or these environmental chambers will be providing values like the temperature or the humidity. They will be in one of these registers. These are different functions from the Modbus protocol. So we will be focusing today on the read multiple holding registers. And this is just an example of what a test system will look like. So we have a control PC where OpenTAP is running. The DUT, which we saw previously in one of the pictures, I mean, this will be inside the environmental chamber, and the environmental chamber will be controlled by the Modbus protocol. There are other things, like, for example, we in Keysight we provide power supplies or DMMs. So this can be controlled by Skippy, traditional Skippy control for instruments, and the device under test can also be controlled by the control PC. In our example of today, we will be simulating an environmental chamber, and we will be controlling it using Modbus. This is an example of reference manual from one of those chambers, and as you can see, they will have a table where they specify all of those registers. In our case, we are interested in these two registers, 61 and 73, which contain the process value for the temperature and the humidity, and the way it's encoded in those registers, in those 16-bit registers that we saw before. So now that we know what we are going to be using, this is Easy Modbus. TCP is an open source implementation of Modbus. You can find it from this website. You can download the source. You can also download some of their tools. And I'm showing here a server simulator, which provides, I mean, the inputs, the coils, the input registers, and the holding registers. So in our example today, we will be using this to simulate an environmental chamber and get some data from it. As part of this exercise, we are also be providing a GitHub repo where you can get this code. Basically this code, what it's doing is accessing the server, and it's updating those two registers, the 73 and 61, and we will be just updating the temperature going up and down. Again, we will provide this source later on. So once you start running that simulator, you will see those two registers, 62 and 74. They will be updated with some values in there, and we will use those values to acquire them from OpenTAP. So we are now on the demo part. So from here on, all the slides will show you how to make the implementation yourself. I will do it really quick here on my computer. I will share my screen. But basically, this is where you download OpenTAP. So you go to this URL, you download and install it on your computer. There is an SDK, and following the instructions on the OpenTAP website, you can install the SDK, which will allow you to get access to all the templates and all the Visual Studio projects that we provide. And then finally, there's a Visual Studio integration. You can download directly from the marketplace of Visual Studio, and this will get you also the templates to build, create projects directly from Visual Studio. So from here, you can either, like I mentioned before, we will provide a GitHub repo where you can find all the source code that we will be presenting today, or we can do it directly with Visual Studio. So that's what I will start showing you. This, like I mentioned before, all of these are the steps that we're going to be following today. And if you follow them on your own, I mean, you can create the project and see the results yourself. In the meantime, let me stop sharing this, and I'll Visual Studio, and I'll show you myself how. So let me start by opening Visual Studio. I'll bring it to this screen right now. And then in here, once you install the tools, the Visual Studio integration, you can create a new project. Then in here, the templates, you can type OpenTAP, and you will see that I have an OpenTAP plugin project. So I will just click on here, click create. Let me just name this as FOSSASIA now, and create. So what this will do is this will get me Visual Studio project, which is ready to be used with OpenTap. What it's giving me right now, it's just a template for a test step. And this is the basic configuration of a test step. So we have some settings that we will be exposing in our GUI. This is the constructor for the class. And then the run is what it gets eventually executed during the test sequence. So for now, if I click on play, let's just do that for now. I can breakpoint in here just to show you how quickly it is to start debugging. I'm waiting for OpenTap to launch. And this is the editor, the community edition. And in here, you can see this is where we will be building our test sequence. These are the settings that are exposed in this region of settings. Each test step will have its own setting. And then on the bottom, we can see all the debug information as we run the test sequence. And here is where we can add the plugins that we are developing for controlling DUTs, for controlling instruments, or logging or publishing results. But in here, if you click on plus, I have my OpenTap plugins FOSSASIA. It's defined in here. So that's where we are finding this initial step. So if I click on add and I click, I can see the step now as part of my test sequence. And and as I mentioned before, these are the test settings. I haven't added anything, so there's nothing in there. If you click on play or run, I can see the breakpoint has been hit, so I can just click F5 and continue the execution. So right now, at this point, we are doing nothing with this. So let's start by creating a new item, adding a new item. And as part of the integration, like I mentioned, once you install it, you will have these templates. You have templates for DUTs, for instruments, for test steps. Those are the most commons. So let me start by adding a new instrument, and I will name it environmental chamber. Let's click on add. And this will get me the template for a basic instrument driver or instrument plugin. So we have, again, we have some settings in here. The open procedure will be executed before the test sequence gets started, and the close will be executed at the end. Once all the test steps have been performed, that's what we will be executed. So let's change one thing. So this is implementing a skippy instrument. So for today, we will be using a basic instrument because we will be communicating using the Modbus. So in here, let's name my environmental chamber. And then in settings, let's add two settings because we will be using an IP address to communicate to the device, which in my case will be local. And then another will be the port where we'll be communicating to Modbus. Another thing is we will be using a private, another thing that I forgot to add. Let's go to the plugin and manage the Nugget packages. I will install the Modbus. Do that really quick. Modbus, install the latest. And once it's installed, start using it here. Modbus or environmental chamber. Okay, we have an error here, so let's include let me bring this from here, which I already have implemented. It's a Modbus client. So right now I have my Modbus client ready here. Let's start by initializing some of the properties during the constructor, and just to avoid time, typing time, I am defaulting to the local host, and this is the port 502 that we will be using. During the open, let's bring this piece of code. I'm going to be replacing, this is when we are using a Skippy instrument. So what I'm going to be doing is I'm instantiating the Modbus client, which is this, name it. And we're going to be using the IP address that we have defined on the port, and then we will be connecting. And then at the end of the execution, we'll be disconnecting from the Modbus client. So this gets us the driver started, and then I have a couple of functions here that will get us the actual data. Those here, and I will be reading the current temperature and the current humidity of the chamber. We will be accessing the registers 61 and 73, and as we read them, we will be also logging information to the debug window and returning the values. So now that we have this, let's add a couple of steps. So I can do add new item, and an open tab test step. Call it read temperature, and this will get me again another template for a blank test tab where we can define settings, and we can define some what we're going to be doing here. So as one of my setting, let me just here doing public environmental chamber, which I already defined in my instrument. This is my instrument, environmental chamber. Let's call it chamber. So this will get me a setting on the GUI, and we will be showing it later, but you will see we can select the chamber that we're going to be using in that particular test step. And then let's just focus on the run. What we're going to be doing in the run, really quick. Basically, what we're going to be doing is we're going to be reading the temperature from our instrument driver, the read current temperature that we just implemented. We will be showing it on the screen, and then we will be publishing. This is the results publish statement that will get this value, the temperature that we just read, available as a result. And then we can grab it, OpenTap will grab it and post it to either a CSV file or a SQL database. We will show it that later. Then at the end, we will be showing the verdict of pass. And then let's do the same thing, but let's do another test step. This case will be the read humidity. So read humidity will be doing basically the same thing. We have an environmental chamber setting, and then instead of reading the temperature in here, we're reading current humidity. We will be displaying the value. We will be publishing as a result, and then we will be upgrading the status to pass. So let's launch the editor. And then one thing that I need to have right now is my server. So this is one of the tools that I mentioned that you can download directly from that website. This is the server. These are the holding registers. If we go to, this is the area where we are going to be updating the values. And I have my simulator, which is here. I just opened this application, which is going to be updating these values on the background. So this is simulating a temperature chamber running, and it's increasing the temperature and it's increasing the humidity as we will be going. So let's see what happened with my OpenTap. It's running here. And let's start by removing this step, and let's add a new instrument. This is what we need to do. Click on the plus add item, We have our environmental chamber instrument. I will add it. We can see the IP address that we already defined on the constructor. These are the values, but the user can change them eventually. Okay, and then as I mentioned before, once you publish those results, you need to tell OpenTAP what to do with those results. So we will be adding a couple of items here. One is the SQLite instrument driver or result listener, and the text we will be using the CSV. CSV will be used later on our demo, and they will be published to this results folder within the OpenTAP installation folder, and it will use this nomenclature to name the file. So click OK, and right now let me click on the plus side again. Let me put this to the side, and we can now work on our test sequence. And I will start by reading the temperature and then reading the humidity. And let me just click on play now, and I will show you what happened here. So again, on the right side, we have the settings. If you remember, I added an environmental chamber. So in here, in case we have multiple types of environmental chambers, you can select which one you want to use for your test execution. Here on the debug screen, we can see these are the values that I logged using the log info statements that I used on my test step. But in here we can see that we read the register 61 and register 73. These are the values that are being updated, and this is my server running. So as you can see, they are being updated every second. I am reading now the values and updating them on my screen. Now for a more advanced example, let me just bring it. These test steps are available as part of the basic installation. So these are flow control, and you can do things like branching, conditional branching, sweep parameters. But in this case, I will just use the repeat, and we will repeat this sequence for a number of times. And then I will add from the basic steps, which are also part of the basic steps available with OpenTAP. I will add a delay. So let me just rearrange this a little bit. Let me put the repeat on top. Then I will select the rest of my test steps, and I will drag them underneath the repeat. And you will see that the execution now, this step will be executing all the steps, which are right now what we call child steps. It will be repeating all of those. So let me just put 30 in here, and I will click run. And now what will happen is this will run for 30 times, and we will be able to put a delay in here, but it was the default value of 0.1 seconds. So I can change this to 1 second. Make it grab the values every second instead of doing it really quick like we just saw. One thing that I wanted to show you here also, I mean, this allows us to run multiple threads in sequence. So that's another capability of OpenTAP. If you want to run different pieces of your test sequence in parallel, that's possible. But in here you can see basically the execution of what we are doing right now. So one of my tools in here, like I mentioned before, is the Run Explorer. That's part of this Test Automation Community Edition. And once it's passed, you will see I have 3 runs already. My last one was this one from that I just run. If I right-click on it, I can click on Plot Selected, and this will open another tool, which is the result viewer. And in here, let me bring it to my screen. You can see that I have the values that we just captured. The temperature is being right now descending from a value of 10 degrees, and it's stopped at -40, and right now it's soaking in that temperature. But it's also updating the value of the humidity. So you can see what we just did is we created a couple of test steps that are reading data from a simulated instrument using Modbus. And once we read those values, we published those values to our results, and we can gather those results or visualize those results using the result viewer. And as part of the demo, I will pass it on to Darwin, who will show us an alternative way of doing this and some other extensibility that you can do with OpenTap.
All right, thank you, Carlos. All right, let me just start sharing my screen.
I need to stop sharing first. Hold on.
Yep.
Yep.
I think the sharing ball is not with me yet. Mario, is it possible for me to start sharing? Okay, yep, now I got it. Finish presentation. Next. Okay. You guys see my screen right now? So.
Yeah, we see it well.
Okay, cool. All right. Thank you, Carlos, for the introduction of the test step creation and also the instrument. So basically right now I'm going to be continuing talking about the extensibility of the OpenTap on two topics, all right, mainly on the component settings and also the tab CLI, the extendability that we can able to achieve through the tab CLI as well. All right, so let's focus deep dive into the component settings. So there are additional, as mentioned by Carlos, there was a test tab settings, instrument settings, and a DUT settings, right? But those are those individuals. So it means like each test tab carries its own settings, right? But if what happens if we want one kind of settings that can be used by instrument, can be also used by DUT or test tabs, right? So this is what they call it as a component settings. And component settings in the OpenTap is divided into two. One is called the global, as indicated by the red. In the GUI aspect, from the talking from the GUI perspective, we call it as a global. Let me just change it to the pointer to laser. So this is called global type, and also there is one we call it as a grouped. As how indicated, it's grouped from the branch, and these are those settings for the branch. And for the demo today, right, we're going to be focusing on creating a global component settings, and we're going to be creating a component settings which holds a value of minimum, and this is been this kind of user can able to key in the values, and then also a maximum value using these two values, right? So we can able to create a kind of a range testing, and that's what we're going to be creating a dummy test step, which takes a user input, and you can able to give in the any guessing value, for example, and then based on that value, we're going to be executing the test, and then see whether it sits within the range of min and max, and therefore the verdict of the test, pass or fail, is corresponds to that. So let's now deep into the get down to the demo. So I have two sections here. All right, I'm still sharing the screen. Yep. Okay. So now I have right now a dummy test tab, which is this. For the sake of time, I have completed a bit of the parts. We have the input value here, okay, and then I have a bit of the run method, and then we have an empty constructor. So right now we're going to create a component setting. The templates for component settings is pretty easy. We can just grab it from just searching for component. Say components, and we have the component settings, and I'm going to be naming it as a FOSSASIA CS, right? Component settings. All right. Now, what we have here is a component settings template. We're going to just remove all these comments. So right now we're going to have, as I mentioned just now, we're going to be implementing, we need two values to be hold, which is an integer value of min, and that goes for the setter, and then we need a maximum. All right, and I'm going to be also defaulting to a default value, but this is not, it is editable because the getter and setters are public. Okay, so these are the only things that we need. And basically right now, if we don't have this, right, you can able to see what I've been mentioned just now as in the presentation. There's only, this is a default. When you open the default editor of OpenTab, this is what you will see. But if you look at the editor right now with our component settings and we compile the editor, we compile the our plugin, and we will start seeing another thing, which is which attack FOSSASIA in. Allow all of that. Just give me a second. Okay, so right now we have an additional FOSSASIA CS. Right, within the FOSSASIA CS, we have our max and the minimum. All right, and right now there is no use case yet because our test tab that we have constructed, the dummy test tab, doesn't have any implementation in the runtime, right, in the run method. So what we're gonna do is we have to go and search for our component settings. And how we're gonna do that? Let's say settings, all right, and then we're gonna say component settings. So this class comes together with the OpenTab library, and then we're gonna get some current. And what we're gonna get is a type of the component setting that we have just created. So we're gonna say type of, and we're gonna say that this is not a component settings that I have. Okay. So the component settings name was FOSSASIA CS. We just copy the name. The namespace was different. Right. So I might need to import that. So because of the namespace are different, so that's the reason. It's under the settings demo. All right. So now we have our type. And when we grab that using this, we can able to see that we're having a component settings type. So we're going to cast this into our component settings type. And therefore, we can able to start reading that values. And how to read those values, we are going to use our functions here. All right. So I'm going to maximize that. All right. All right. So now we're gonna use this function. So what basically this function does is checks for the min max, and then when it's true, it will say pass. If it's out of the range, it will say fail. All right. So this is the way we can able to get our current settings, and we can able to implement that into our runtime and then execute the upgrade the verdict. The function upgrade the verdict is literally how we can in the open tab we can upgrade the verdict so that it can say pass or fail. Now let's see that in action. Right now we have our settings, min max, which is at 101 as a minimum. Let's say in FOSSASIA, we have this. Inside here, we have our user input. Let's say if I put in a value null, and when I run it, it will say fail because it doesn't fit in the value within the, it doesn't fall within the 1 and 100. So if I put it here, value 5, we can able to see that it's able to grab the component settings, the value coming from min max coming from this component setting, and this can be crossed, can be shared across your instrument, DUT, and test tabs. Okay. It means that I can have multiple test tabs and all of them always refer to that one component settings min max value. Okay, so that is about component settings. Now let's deep dive into the next demo. Let me just stop all this. Next, we have CLI actions. So when we install our OpenTab, right, we will be given a default things or commands that can be executed across the tab. So these are those default CLI, fresh copy. Okay, we want to do what we're going to right now try to extend those CLI so that we can able to add some commands, like for example in this result plotter, for example, and this result plotter is something that we created for this demo. These are the use cases. So their use cases can be multiples, like you would like to execute OpenTab directly from just calling the OpenTab. You want to execute a certain executables that can be done through this activity right now we're going to do. And also another thing is to do a specific actions for your test. So you want to do a certain specific action, and you want to do that prior for your run actions, for your run commands, right? So you can also embed that particular command, extend it using this exercise right now, which we're going to do. So what we're going to do right now is we're going to try to create a scenario whereby we're going to execute, we're going to run a Python script from the open tab. All right. So behind the hood is going to call the Python and stuff like that, but the as a part of the user, you will be only executing from open tab, the tab.exe, and then you can able to run your command and pass in those the scripts, and you can able to execute the Python script. All right. So let's look at it in action in the demo. Jump into the second part, the CLI action demo. So I've kind of like prepared some of those Python processing part. So all of this script is about a logic on how to create from the C#. This is nothing to do with OpenTab at all. It is only basically calling the process, how .NET can able to call another process, and then we are just going to be calling this logic so that our CLI can able to execute this class activities, the function execute within the OpenTab CLI. So what we will do is we need a Python path. The Python path is a folder where the python.exe, if it's Windows, sits, and the script path itself. Okay, so the rest is .NET's way of calling external executables. So let's look into this the class FOSSASIA CLI class. So FOSSASIA CLI class, I've prepared here just a basic class. Okay, it has nothing unique. It only using the namespace OpenTab. So we're going to be extending. So we're going to be bringing in another namespace called the CLI, OpenTab CLI, and we're going to be implementing a class called iCLI action into our FOSSASIA CLI, right? So let's implement those interface, and these are the function. This is the function that we need to execute, all right? So within this method, we are going to be instantiating our the Python process class, and then execute the so we need two different, so as the Python process requires two variables, Python part and also the script, so we're going to be handling that via here. And how? So let's put it a public, say string. I'm going to replace this with the Python part, right? And I'm going to be putting a string name, and I'm going to replace this with the script. The Python script itself. So how are we going to let know the OpenTab to know this is not just a normal variable, but it's a command line variable. So I'm going to be, there is an attribute called the command line arguments, and we're going to be passing in the string name. So this is a string name. It means what's the command line full name. All right, let's say Python, and then give some description. Python path for the folder. And I'm going to give a short name for it. The short name for here is I'm going to be using P, right? So let's just put a description here. Description, all right. So and the next one, we are going to be passing this value as well from the command line. And we're going to say this is a script. In the descriptions, let's say in script, and the short name we're going to say stands for F as a file. Okay, so now we have two variables which the user will able to key in from the OpenTab CLI, and then we're going to be instantiating the process, the Python process, equals to Python process, and we're going to pass in the it's going to be a new Python process, and we're going to pass in the Python path and the script. And And then we're going to be calling the Python process execute. Dot execute, and it basically that is it. And it returns what it returns. It returns the exit code, and the exit code is an integer. And this method also requires an integer as a return. We're going to just return this. Okay, and part of the public. I wonder why it has been brought in here. All right. Wait a minute. Okay, I'm going to just replace this. There's something to do. Just do that. Okay. So now our Python CLI extension has been completed. So I would like to show you what the CLI looks like before we start building this. This project. Okay. So I'm inside my debug folder, bin debug folder, and this is what I have. What those type CLI can do. All right, those commands that's available, and we will later see our what we have built. Right, so let's see. Yep, we're going to see the Python terminal itself. We're going to see this Python terminal available. Okay, we're going to start building this solution. So it succeeded, and when I execute the tab exe, I can able to see these another extended commands available for us, and we can able to execute that. So let's say tab.exe. I'm going to say Python terminal, and then let's say ask for help, and we will see that we need to get a Python path and a Python script, and we're going to do that as well. So let's see, the Python path will be sitting at I have my folder here, so I'm using the Anaconda, so that I have open tab, and also I'm going to be passing in a script. The script that I'm going to be passing in through for this use case is I'm going to be passing it through a script, Python script from here. So this Python script, right, is basically does only one thing. When it's successfully executed, we will able to see welcome to FOSSASIA 2020, all right, and the rest of it is a Python script from OpenTab CLI. So we're going to be using that path, this path. I'm going to copy the full path and pass it as a parameter. Ooh, it just goes off. I'm going to be copying P, this, and then the F for the path. And I need the Python script, copy path. I'm going to paste that, and I'm going to execute it. So right now what you can say, okay, let me just execute one more time. So what we have achieved here is be able to use a tab exe and then able to execute an external different language application. So welcome to FOSSASIA was being written back to us in the console. So the boundary is limitless. You can able to do anything from the tab exe with the extendability. So right now we have learned about component settings, and also we have learned about how to extend the CLI actions. So to make it more complex, all right, I'm going to be doing we built a Python basically using a Plotly, an open source. Let me just show you the slide. So what we did is we built a Plotly chartable. So it's like we call it as a result plotter, and then using a Plotly library is an open source Python based. The charts have been we can view it using browser. So we have an endpoint to view that. So this basically summarizes the component setting and the CLI. So we're going to use both of this knowledge and then build this. And the overall application was built basically from here. All right. And then we're going to look into the, not to say due to the time constraint that we cannot build from scratch down, I have built it everything up front, and then we can able to look at the applications using this test CSV that just now Carlos just run, and then we can able to plot the charts as how the result we will, but this is a simpler version, but just in a POC kind of concept that the capabilities are there. Okay, so right now I have this application here and the result plotter. So I'm going to be passing in the temperature CSV, and this is not the one currently Carlos run, but this is the one that we done yesterday for the preparation of this presentation. And then I pass in the selected Python, and I have this button start the plotter, and I'm going to pass in the default port as 8050, and then we're going to start it. I have this browser, so let's see. So behind here, I have a browser, and it's pointing to 8050. So it has two buttons, remove and add. I would like to close this up. Right. So we have, when we click in the add chart, we can able to select, for example, line chart, and then we can able to copy it, and we can able to read the temperature, and we select the x-axis to be index and also the temperature. So we can view what happened for our test case, and this is all basically runs from the tab CLI, the concept, the logics, all using Plotly. So the extendability of OpenTab is seamlessly integrated. You don't have to use a command line to do that. You can able to seamlessly do it, and also you can use the command line, but all the command line, the actions can also be used the tab CLI. All right, so the tab result plotter, you pass in the parameters and you start the test, you can able to do that as well. So I'm going to do that. I'm going to right now stop the plotter, which the editor have started up for us. All right, we're going to stop that, and it stopped. We're gonna look at it, confirm it, it's been stopped. Yes, the browser stopped it. And we're gonna pass in another, this test, we're gonna be pushing in another test tab so that we can see the series. So is this, for this test, for this demo, I'm using another test tab, another test results. Okay, voltage current kind of concept demo was that the result from that. So we're going to look at the bar chart, and therefore we have two series, charge and also discharge. So let's look into the charge first, and I'm going to for the x-axis, I'm going to use the x-axis sample number, and for the y-axis voltage, we can able to see the voltage increasing for the charge, and then we're going to add in another chart down here. We're going to put in a line chart, and in this time we're going to see what is the discharge, what happened in the discharge with the same x-axis and the voltage. So we can see that the value has been decreasing. Okay, so this overall the result plotter, it will be later open source as well, and once it's done, it will be available in the our OpenTab package repository. Okay, so I have came into my end of my presentation. So that is the end of the demo for today. So right now, as to summarize all from what we have presented and so on, right? OpenTab basically sits on top of a very strong, in terms of R&D and also manufacturing, it has been very strong. And as how we have presented the extendability, what you can able to do with OpenTab, what you can do is just limitless. The extendability concept is the core concept of OpenTab. It's kind of like Lego stacking. You can able to stack your things that you want to build and then able to extend from the base OpenTab itself. Okay, and we would like to also invite all of you to join the let me just show this. So this is our GitHub page, and give a star for us for what the effort that we are doing. You know, the more the likes and the stars increases, it's going to give us more and more energy to kickstart put more effort into it and solve all those issues that's available. So the stars matters, and please, if you like OpenTab, and then use OpenTab, and then do also engage with us in the forum whenever you have any issues. We are eager to help you out. We are there. The community is there as well. And then this is our home page, and also you can able to read it all those documentations that we have just showed you. If you wanted to deep dive into that, go into the documentations, and also all the repositories that's been open sourced or there are certain license. So we have here the package.opentop.io. So all of these are mostly all the open sourced, and we as a part of the open source engagement, we have released a lot of basic controllers like instruments. There are tons of it. So I'm gonna go few of it, and this is I'm basically filtering from basic control, those packages, that basic control packages that you can able to right now deep dive into it, and then maybe one of those instruments that you have it in your in spare, and then you want to start playing with the OpenTap, utilize one of those instruments. You don't need to build by yourself. It's all open source. The source available, all right? And all of those packages there are tons of packages available for you as well in the repository. Okay, so I think we can ask Brandon as well to join in. I think we're gonna end the
Okay, thank you very much. That was very impressive.
Thank you.
And yeah, Brian, if you want to join, but we can also go through a few questions. One question is how to optimize the resource usage across multiple instruments.
Result users across multiple.
I'm not sure if that is correct, but yeah, I think Sahil, the question is from you. I think you need to be a little bit more specific. If you could follow up and add some details to this question, because what do you mean the resource usage in the automation, how to track it, or what do you mean? Okay, so Sahil says he will add more details to his question. Then another question is, but I think you have answered it a lot already, about functions of OpenTap. Do you have some more details on the functions of OpenTap? I mean, we can't expect everything here. It's an introductory workshop. So, but if you can give a little bit of an outlook, what other functions are there?
Anybody want to take, or should I?
Go ahead, Darwin.
Okay. So basically, as in the core itself, right? It's the tap engine is a test sequencer. All right, we shouldn't be forgetting that. That's the core of the OpenTap. But the functions itself, so it's basically uses for testing purposes and all those sequencing, that whatever needs a sequencing kind of activities, that's best to be put into OpenTap. And other functions that the rest of the extendability concept itself, it is being built, the OpenTap has been built in a way that you can able to build, as how I just put in my thought minds, right? You can able to build stuff that you think that you want to hey, I want to put in some other application running. It's I want to execute certain things at this point of time while I'm running some test. You can do that with OpenTap. It's just a matter of extending those capabilities using those those things that we have showcased right now are just a 4 components that OpenTap can able to extend for you, freely, open sourced, and so that's basically what I have understood from the functions of OpenTap.
Yeah, and so. The question is, you also mentioned in your presentation that they are proprietary products, and now of course we have OpenTap. I mean, it's great because you can just dive in even step by step, whereas if you buy a very expensive proprietary solution, you don't know, right? Does it fulfill your needs and so on. But just to give here people who work in the industry an idea also, what are proprietary products that you would compare with OpenTap?
Yeah, so there's a couple. I would say Test Stand from NI is one, and iTest from Spirent is another. But really, I would say what we compete with the most is actually people that have built their own tools within their companies, right? They've done kind of they have a goal of testing something, and so they said, well, we'll build this tool to test it, and then it ends up being kind of a burden to maintain that ultimately within their company, and they're not able to fully extend it. It usually doesn't have a lot of design thought into it. It's just barely enough to do our testing, and then they have to try to find ways to add more and more features and bring them along, and then can't connect into anything else either. So there are definitely kind of proprietary ones with the examples I gave, but most often what we see is actually just the other internal tools that people have created that aren't really set up in a way to be used and developed on Boil.
Yeah. And what's your experience of projects or like test automation engineers who want to switch to OpenTAP? I think if they build a lot of internal tools, it's also the question, can they like switch step by step of switching some functions? I think it's very complex.
Yeah, definitely, and that's one of the bigger struggles. But kind of like what Darwin showed, there's ways to kind of connect into other tools without having to like fundamentally rewrite everything. And I think that's one of the advantages that we have ultimately, is that there are ways to natively write tests in OpenTAP, but also we try to be kind of agnostic and connect into multiple different things. And that's actually one of the main applications that we see is, a lot of companies have a bunch of these different tools that can only be used independently, and they kind of use OpenTAP as that layer to tie them together. And so it allows you to not have to rewrite everything and retest and revalidate all of the components, but you can sort of integrate them together, use them at a higher level in a more kind of common and standard way. But yeah, definitely that's a struggle that people have. Obviously, when people that we're talking to in our industry, they're not coming from nothing in most cases, right? They're usually coming from existing tools. Oftentimes they're tools that they've been using for 10 or 15 or more years that they're trying to figure out how to maintain and use. So over time, we generally see people do stuff more and more natively, but as they get started, it's a lot more of kind of integration and connecting into existing pieces.
Yeah, and so you're already supporting some hardware, like for example the Pocket Science Lab. By the way, for anyone who's interested in this, there was this workshop. It's also on YouTube. So you showed how to use the Python library of Pocket Science Lab and the hardware. Do you have other hardware as a reference? For example, here's also one question related. Do you have already something in the medical sector? Somebody really interested in biotech? I don't know. Like, what is your like information on that? Do you have any specific examples here?
Yeah, so I mean, on the Pocket Science Lab side, that I think that was sort of how we initially got connected to you guys, was that we found that as again, kind of an easy way to get into the space. Like, obviously from a Keysight perspective, we have oscilloscopes and power supplies, but they're thousands of dollars, so it's not exactly an easy entry point for a lot of people. And that's what we really liked about the Pocket Science Lab side of things, is you can do a lot of stuff for very low cost, and it also kind of fits into that test and measurement space. So we have connections into tools like that, or like the more generic stuff like Raspberry Pis and Arduinos, and then from like the medical side of things specifically, we do a lot of things on like the RF testing side of things. We do a lot of stuff where we end up being used because we have basically the whole traceability aspect, right? You know exactly what test was run, what settings were used, what versions of plugins were used, and that's kind of a big aspect on the medical side of things for audits and other things, is making sure that you can validate exactly how something was tested. And that's so less about the specific pieces, I guess, that are used in that space, but kind of some of the aspects around traceability that becomes really important.
Okay, cool.
But I don't know, I see your email, so I will reach out to you on that for more details on stuff.
So I also saw that on your website you're looking for people who would like to work in the sector. Do you have like specific regions where you would like to interact and potentially look for people who would like to join Keysight?
Yeah, I mean, so we have people all over the world. Someone asked the question of where we're located. I'm in Colorado. Carlos is in Chicago, and Darwin's in Singapore. So we have the teams kind of spread out. We have some, our R&D team is actually in Denmark. We have various other people in Singapore as well. So we're really looking forward to when we can actually do some stuff in person with you guys there. But yeah, we have people kind of all over the world. Keysight in general is like 20,000 person company, more or less. Our team is around kind of 25 spread out everywhere. And so yeah, if you're interested on that side as well, you can reach out to me directly, whether it's from that perspective or if it's just interacting, contributing back on the forum or with other plugins. We're interested in all areas of things.
Okay, very cool. Yeah, we also have regularly people from Keysight reaching out to us. I think it's not always from your team, but there's a huge presence here in Germany, for example, as well, in the south, where all these automobile manufacturers are based. And yeah, it's great to see more and more connections from you guys to the free and open source community and open hardware, of course, as well. So thank you very much for that. It's great. Like, we took a bit more time, but I think it was really important to get inside, right? Because you showed it step by step, and it's very good for people as a reference. They can also watch that later and learn about it. So definitely, we appreciate it a lot, and yeah, we hope to foster more connections as we're opening up and doing some summer workshops, winter workshops, or whatever is possible. So let's keep in touch, and yeah, hope to see you guys soon. Thanks a lot for.
Yep, definitely. Thank you.
Thank you.
Yep,
Thank
thanks
you for
everyone
having
for the questions and everything.
I just realized you guys are in the middle of the night in the US. So, oh my God, thank you very much.
It's almost the morning now.
Keep you up so much. Okay, and thanks, Darwin. So good.
Thank you. Thanks.
Talk to you soon.
Thanks, everybody.
Bye-bye.
Bye.
Bye.
Okay. So that was nice, and we're coming back into the session. And Sean, has a great session coming up. Sean, are you there? I think you're already set with the microphone and everything. Yes, I can see you. Hello. Sorry for this delay. I mean, as you see, so many cool topics, and I think a slight delay is we are still okay in time. I have a question. Are you doing test automation? Are you doing anything in this area? Are you using any tools?
Test automation. Well, I gave a talk a couple of years ago at LinuxConf, where we ended up doing our own test automation for factory end-of-line testing using a framework called Exclave, which was a thing we put together that basically glues together Python and test scripts and things like that. That ended up working out really well for us in the factory line in China, but we're not doing any sort of automated testing such that OpenTap seems to be. But it does seem like a good package for that sort of testing.
Okay, nice. Well, definitely let me know how it is for you. You're really an expert in open hardware and automation, all these things. And yeah, with the Pocket Science Lab, we also try to learn as much as possible about this, and I would definitely value your insights in future about this. But now you have your own session. I'm sorry to hijack you and always ask interesting questions. Sean, I will let you go ahead with your session in a moment, and you will be talking about Renode and Easy CI for your weird hardware. So I'm looking forward to learn about what is here weird hardware, and about Sean. Sean is actually well known in the FOSSASIA community through a lot of collaborations with different engineers. Sean has a company which is called FOSN, Fusion Pta Limited. And Sean has been in the hardware space for more than 20 years. He started writing device firmware for embedded Linux at Chumby, and then worked his way down the stack, all the way developing open hardware and software along with Andrew Bunny Huang. And he created the Novena open source laptop complete with an FPGA and open schematics. They went on to create circuit stickers, which contained 48 megahertz device programmed via audio, complete with a USB stack, yeah, and written completely in software. Wow. More recently, he has created FOMU, the world's smallest FPGA development board that's tiny enough to fit entirely into a USB-A port. I also have one somewhere, and I know a lot of people have one. And yeah, through it all, he has made sure to release his hardware and software designs so that others may see what hardware projects look like on the inside. So pretty exciting, and I think a lot of people have some connections to you. I leave you to tell us more about Renode now. Thank you very much for joining us.
Well, thank you for having me, Mario. So for those of you who are out there who are on a lower bandwidth connection, if you want to follow along, these slides are available on the internet, p.zobs.io/FA22. This will actually synchronize with the presentation that we're doing, so you can follow along if you can't get the video feed. Just a little bit about me. Mario gave a pretty good introduction. I'm here based in Singapore, and as he mentioned, I tend to do weird hardware. There's a picture there of FOMU, probably the world's smallest FPGA development board, can fit inside of a USB port. There's also the Chibitronics, which is a circuit stickers project we did that actually lets you program the device via audio, and you can actually program in C, Arduino style language using your phone. Lately, I've been working with the Betrusted Secure Communication Platform, which is multiple FPGAs working together with the CPU and all the logic written in high-level language that gets compiled down to Verilog and runs entirely on this open platform. This talk is going to be about Renode. I do not work for Antmicro, the people who create Renode. I just find it really useful software, and I hope that by the end of this, maybe you'll find it useful too. Now, Mario did mention that this talk is about weird hardware, and what do I mean when I say weird hardware? Weird hardware to me is hardware that there is only one of in the world, or maybe just a few, usually because you just made it. Possibly you're beginning production, or it's something special for a particular project you have, but for whatever reason, it's somewhat bespoke, and there isn't another person in the world who has your exact hardware. Weird hardware could also be just something you have that you found somewhere that you're trying to understand, possibly reverse engineer. Now, just be clear, when I say weird hardware, I'm referring to devices that have an ARM, i386 PowerPC, RISC-V, SPARC, or Extensa core inside. Unfortunately, Renode only supports those platforms. It doesn't support anything like a CS2230 or an 8051. Unfortunately, those sorts of devices can't be emulated in real time on Renode. You'll have to use something else or just build a simulated model of that particular device. Renode itself is a multi-node emulator. It's extensible with C# and Python, very similar to how OpenTAP is extensible in C# and Python. It is available and can run fully on Windows, Mac, and Linux. And it's MIT licensed, so you don't have to worry too much about GPL or anything like that. And here's just a picture of what the Renode console ends up looking like. Now, I'm going to start just by asking a question. When I say emulator, what comes to mind? For a lot of people, it's going to be something like a whole system emulator. This is a picture of a Nintendo emulator running on my PC. It's called FCEUX, and it lets me play games that were written for the Nintendo Entertainment System, which is a console from the 80s. As far as the game is concerned, it's running on a real Nintendo. It thinks it's outputting to a CRT screen. It thinks it's reading a gamepad, when in actuality, it's outputting to a window on my desktop, and it's reading from my keyboard. This emulator means that software that was written a long time ago is not going to be obsolete. It means we can still use it today as if it were the 80s. In fact, you can see it says copyright 1985, Nintendo. So in addition to preserving software, emulators can give us greater insight into the software that we're running. For example, this is the same emulator with the debug window opened up. And you can see here we can have a live disassembly of the game as it's running. We can see the memory as it's running. This is the sort of thing that would be difficult or impossible to get working on the real hardware. And so by having an emulator, we can actually get greater insight into the system than if we had real hardware. Now, asking the question again, what is an emulator? Is this an emulator? I would say yes. And I don't mean the BBS that I'm dialing into right there. I mean the window on the outside is an emulator that is emulating this guy. So this is a DEC VT100 glass teletype from 1978. It's at I believe this is from the Computer History Museum. It is a alternative to what was prevalent at the time, which was typewriters and printers. So instead of wasting paper, you can connect a glass terminal, a VT100, to your mainframe and type commands in real time that way. Now, the previous page, this is in no way emulating this. This comes from an era when they would publish the schematics in the reference manual, and this is what it actually looks like on the inside. It's got video control circuitry, it's got something to read the keyboard. This is not the sort of thing that you really need to emulate when you are typing in a terminal on your desktop. You don't need to be emulating the firmware of the original Intel 8080. You just want to get enough commands. You want to be able to understand the commands such as move the cursor around or input the colors if that is supported. So basically, emulation depends on your goals. For a VT100 terminal, usually the emulation is to be able to get the other side to give you the commands that it intends, which is another way of saying that emulation is actually a lie. We're lying to the game that says we're a real Nintendo. We're lying to the thing we're connecting to, saying that we're a real VT100, even though I'm sure most people have never actually used one, myself included, if I'm honest. So with that in mind, emulation is a lie. We want to emulate a computer. We can ask the next question, what is a computer? What does it mean for a device to be a computer? Well, I'm just going to say that in my mind, a computer is a system of devices, one or more processors, one or more buses, one or more blocks of memory, and if we're not building a Turing machine that is infinite paper tape, it has some input and output. And for this purpose, I am going to refer to this guy, which is a Blue NRG2. It's a Bluetooth chip. It's fairly simple, low power, but I would argue that it is a microcontroller, a system on a chip. For our purposes, it is a computer. And when you work with a microcontroller, you can usually get a PDF, which usually starts with something like this that gives you the bullet points of the chip, followed by a lot of information about how the chip works. And this is from the reference manual for the Blue NRG. If you open the manual and you go to one of the first few chapters, you'll get this. Now, it's really not so important what the blocks are, but you do get a block diagram that tells you how the chip is arranged on the inside. I'm just going to prefix this by saying currently Renode does not support the Blue NRG. This is a chip that is unknown to Renode. So we're going to figure out what it would take for Renode to be able to understand this sort of chip. Now, when you're looking at a block diagram like this, there does seem to be a lot there, and there's a lot that we would have to get working in order to get this working with an emulator. Except not really. It turns out we can actually ignore anything that I've crossed out in red here. Things like there is a Bluetooth modulator and a Bluetooth demodulator that go from the Bluetooth encoder to the antenna. We don't really need to emulate that. We don't need to do all of the real-time calculations, the IQ encoders and decoders. We could just cross that out. This also has a bunch of bridges that go from, for example, the AHB bus to the AXI bus. We don't need to emulate those for our purpose. In fact, if you're writing code for this chip, you rarely need to know about those to begin with. So we'll just cross them off, ignore them. Great. We have in yellow here a CPU, a Cortex M0, which is great because that is a standard ARM M0 CPU. So that is going to be well supported by most emulators out there, including Renode. So great, we have one CPU. We have things in green that are memory. There's the SRAM, two 12-kilobyte banks. There's a 1 kilobyte of, for some reason, I guess it's public key memory that's dedicated to that. And there's 256K of flash. Now I'm going to treat all of this as memory. It's just bits and bytes in a memory array that isn't really doing much except storing data. So there's nothing special about these areas of memory, except the flash happens to be read-only, and the SRAM can go away when it goes into a low power state. It doesn't matter. For our purposes, this is just memory. And then we have the rest of the blocks that are all outlined in purple here, and these are peripherals. These are the spice that gives a chip its specialness. Every chip is going to have a different set of peripherals and a different set of addresses, and these are what separates one particular microcontroller from another. Now, the way you access all of these memories and peripherals is by memory. So most modern systems are memory mapped. There are port mapped systems, but most modern devices are memory mapped, where things like flash and RAM are just addresses in memory. But also, the peripherals are memory as well. You can see on the screen, starting at address 4000, 0000, we have GPIOs. These are input-output pins. So depending on the configuration, reading and writing to these areas of memory will cause pins to either go high or low. There's also some other peripherals on here, for example, the flash controller, the system controller, the UART, which is just another name for a serial port, and so on. There's so many peripherals. Each one of them gets its own address that I ran out of space on the bottom of the screen, which means we can boil that complicated diagram down to basically a CPU on one side, some sort of memory bus in the middle, and then devices on that bus on the right. RAM, flash, UART, SPI, and so on. Now, how does this relate to Renode? Well, it turns out to be really easy to define at least the skeleton of this in Renode. For start, we have the flash and the SRAM, and we're using the memory.mapped memory block here, and we're just placing it on that system bus. The first one is at offset 1004, 0000, and we give it a size that we get from the reference manual. And the same thing, SRAM is at offset 2000, 0000. We're just copying these numbers straight out of the data sheet. Notice how we don't specify that flash is read-only. It might be that there's an option in the mapped memory block to specify flash is read-only. But it turns out that in practice that doesn't matter, because very few real programs try to write to flash, because that would be an error. It could be that if we want to test that that doesn't work, we can add that as a feature. But for now, I'm not going to bother, because we just want to get something working. Then we add the CPU to the sys bus. So remember, with this, we can have multiple CPUs sitting on the bus at the same time. We specify its CPU type, Cortex M0+, which again is a very common low-end microcontroller that you find in all sorts of very tiny devices. We specify the performance here, and this is just a number that you can get either out of the data sheet or just invent one. You don't want it to be too high, because then you're simulating a device that's much faster than the one you're actually simulating. But 24 is usually good enough. Usually it's about 1 megahertz, 1 MIPS per megahertz, depending on the architecture you're using. And then at the end, we actually attach what's called an NVIC. And this is kind of a quirk of ARM Cortex devices. One of the nice things that ARM has done is that they've said for the M series, they're going to give a standard set of peripherals. And the NVIC is one of those. That's the Nested Vectored Interrupt Controller that is a standard way of handling interrupts. It also has things like a SysTick timer that is a universal way of firing interrupts at a regular interval. And it's this combination of NVIC plus SysTick plus some other peripherals that actually makes it really easy to port operating systems from one Cortex-M chip to another, even across different vendors. So we put these all together in a file called bluenrg1.repl. That is the Renode platform file that defines our platform. Now, there are a couple of things that we need to talk about. What about loading firmware? And what about adding those peripherals in purple? Because remember, peripherals are going to be a lot more challenging than memory. Well, rhetorical question, what is firmware? Well, you might say that firmware is a series of instructions that are executed by the CPU in order to accomplish a task. And I think that's an overly complicated definition. For our purposes, firmware is memory. It doesn't really matter what it does. It doesn't even have to be valid. It could be you're emulating an emulator, in which case it's not real instructions. It doesn't matter. The firmware is just memory that happens to be loaded somewhere. So in Renode, it's actually really easy to load firmware. If you're developing, you build it, your compiler toolchain usually generates an ELF file. You load that ELF file into Renode by just saying sysbus load ELF, and then your firmware file. File names are prefixed by @ in Renode. So this is saying sysbus load ELF, the file called firmware.elf. And what that will do is it will use the ELF loader built into Renode to unpack your ELF file into memory. So, for example, it may be that flash is at one address and then the data section is another. This will do all of that unpacking for you, so your image will be ready to run in memory, and you can just jump to the start address. If you don't have an ELF file, if you just have a bin file, for example, off of an SPI flash chip, or maybe that's what your developer tool generates, you can specify sysbus load binary and then give it a file name and an offset. Remember that flash was located at 1004.0000 on our target BlueNRG1. So that's why I've specified sysbus load binary 1004.0000. And this, you need to ask the question, how does this interact with the random developer vendor tool that you've got? Hopefully it produces ELF files. And if not, we'll just use the load binary to load the hex or the binary file. Unfortunately, if your tool generates a custom firmware format like updaters or something like that, you will need to unpack them first before feeding it into Renode. But for the most part, just treat it as bytes that get loaded into memory somewhere. What about new peripherals? When doing any sort of big project like emulating a brand new device, it really is all about the small victories. If you can make something that gives a high reward, the most value you can get for the least amount of effort will at least get you started on the project. If your goal is to emulate the entire system, you're going to burn out before you get anywhere close to emulating the whole system. So start small. And it turns out that serial ports are super rewarding because you can get text out and see what's going on and run a lot of software very quickly. They're also usually very simple, and they're easy to script once you get a serial port written. So going back to this document, this table from the reference manual, we can see that address 4030.0000 is a UART, and that is where the UART peripheral lives. And the UART peripheral is full of registers. Now, what is a register? A register is just an area of memory that has some special property when you read or write. And in the UART register section of the reference manual, we have two registers here. There was a page break after this, so I only copied two registers, but you could see address 0 is DR, that's the data register, and offset 4 is the RSR, the receive status register. And these are going to be at 4030.0000 and 4030.0004. What do these special addresses mean? Well, even further down, there is a documentation for each individual register. So this is the documentation for DR. We could see that bits 0 through 7 are the data register. You read from that to read data. You write to that to transmit data. And then there's some other flags as well. Okay, that is useful. So we can think that if we want to create a peripheral, we want to make it so that when they write to this address, we send it out the serial port. And when they read from it, we get the data that the user typed in or the test harness wrote or something like that. But there's an interesting thing there. Address 0 is DR, address 4 is RSR. Those numbers look kind of familiar. This is the reference manual from CC2538, which is a chip from a different vendor that has a radio in it. And we look at their UART. Address 0 is this thing called DR. Address 4 is this thing called UART RSR. And address 4, they also have this thing called UART ECR. Okay. Looking at a Raspberry Pi, the Broadcom chip that is used in the Raspberry Pi has the same thing. Address 0 is the data register. Address 4 is this register they've called RSR ECR. And then they have some other registers below. And a hint as to what's going on is actually up at the top. It says the PL011 USRT is mapped onto the base address. And if you look that up, you can actually see that the PL011 is a prime cell UART from ARM. And they have the technical reference manual for it. Because what happens is it's really hard to design a chip. And what chip designers do is they want to reuse as much intellectual property, as much IP as they can. So companies such as ARM not only will sell you the CPU core, they'll also sell you peripherals that go around it. And so because ARM makes the prime cell UART and most companies don't want to design their own UART, they just buy the IP from ARM, slot it into their system, and now they have a UART that's compatible with any other chip that uses a PL011. And this is such a common core that Renode actually ships with a PL011 driver. So in order to instantiate a PL011 onto our sysbus, we just say uart.pl011 at sysbus 40300000. We also specify the NVIC interrupt is 10, and we get that from a different area in the reference manual. So now we want to set up Renode. First, we load the platform definition file that we just defined. Then we load a binary of BLE chat server. Now, you'll notice I'm loading a binary here and not an ELF file. And that's because these demonstration programs came directly from ST. I didn't actually compile the source because I wasn't sure how to set up their developer environment. But I knew that this code ran on real hardware, so I just decided to load it into the emulator at address 10040000, just like the bootloader would do in the real device. Then you do some ARM-specific things, setting the vector table offset, which is where the interrupts live. Most of the time, this will be at address 0, but because on this particular chip, the firmware lives at 1004, we need to reset the vector table offset. It's just a single command. And then we set the stack pointer and program counter. Again, this is the sort of thing that any ARM chip does. The hardware actually does this on its own, except it usually sets SP to add the value at address 0 and the PC to address 4. It's just because Flash is at a weird place on this chip that it is at this weird address. Because remember, this is all about getting weird hardware to work. This is really the extent of the weirdness, because at the end we hit start, and there's our whole setup. We're going to call this blueenergy1.resc. That is the Renode script. And we feed this into Renode, and there we go. We get output. We get the firmware that comes from ST running in our virtual system, outputting a message that says it managed to initialize the UART. And that's cool. That's huge. That's before Renode, you'd have to do something like recompile QEMU in order to get this working. And it wouldn't work on Windows, Mac, or Linux. You'd have to have a different version for each platform. This is just some scripting that we do in order to get it working. So number one, always check for block reuse, because companies frequently use blocks across different designs, and that can save you from just having to re-implement it from scratch. It may be that a block is slightly different, in which case you'll have to copy the existing design and modify it slightly. Maybe the addresses are different, but try and use a design if you can. Now, peripherals can be developed surprisingly quickly. I was skeptical until I saw this, but I was at the Hackaday SuperCon in 2019, and we were just bringing up the Betrusted platform. So this is an early Betrusted prototype. It is on the left. On the right is a Raspberry Pi with a debug hat that we use for serial I/O and also SPI flash. So what would happen is you do the development on your desktop, upload it to the Raspberry Pi, which would then program the flash chip in the Betrusted and give you feedback over serial as to how this device was running. So you can see here, this is Bunny in Singapore running a demo that is a ball bouncing and is also reading some values and putting them on the screen. This is 17th November 2019, very early stuff. And so I was at Hackaday SuperCon, and the Ant Micro people were there, and they said, yeah, we could emulate that, no problem. It should be doable. RISC-V CPU core, okay. Now, with Betrusted, because it's an FPGA, we actually have to do everything ourselves. We use LightX SoC in order to design the FPGA. And as part of the build process, we actually generate our own reference manuals. This is an example of what our reference manuals look like. There's a link at the bottom in case you want to go take a look, ci.betrusted.io. These are actually generated every time we rebuild the firmware. So I sent this to the Renode guys. I gave them the flash image that Bunny was using here. So he just, instead of sending it to the device in the Raspberry Pi, he just sent it to me over Telegram. And so I gave that to the Renode people who were at Hackaday. I gave them a link to this reference manual, and I told them a little bit about the layout of the screen and the frame buffer and all that. And she said, yeah, we can do that in a day. It'll take a day, no problem. And I said, a day, really? Oh, okay. And then I went to go see a conference or a talk, and an hour later, I get a call, and he says, come here, I got something to show you. And I go over to his desk, and he has this running in his machine after an hour. So it turns out that it's really easy to create new peripherals. This isn't even really a patched version of Renode. This is a stock version of Renode that he's running here. He's got our software loaded. He's got the frame buffer working. He's got the timer working. It's a bit slow compared to real hardware, but that's just because the peripherals are completely unoptimized. He managed to get it working in an hour, and I've just never seen anything so amazing. He got the ball bouncing working. It's delightful. Like, okay, this is a cool piece of software. And so that is actually what started to get me to use it for the Betrusted project. Now, remember we had the Nintendo emulator that gives you visibility into the system. There are some things that you can get with emulation that you can't get with real hardware. One of the things is that in the real hardware, we have one serial port. Because it's a Raspberry Pi, there's only one serial port that's brought out to the device under test. And so to get around that, there is this register called UART cell, where you can select which one of the logical UARTs inside the system on a chip in Betrusted will get sent to the Raspberry Pi. There's 2 bits, which gives you 4 options. With Renode, I don't bother to emulate that. I just open up 2 serial ports. Like, I can put as many serial ports on the screen as you want. Just open up another window. This is something you can't do in real hardware because you're limited to the number of wires, but in emulation, we can have as many serial ports as you want. One other story about this, getting hardware to users. It's a lot easier to send somebody a download link than it is to send them hardware. And in fact, it's easier to patch Renode or even an FPGA hardware than it is to patch real hardware. So this mess of wires is what we call the engine. It is a cryptographic acceleration engine because modern cryptographic primitives, particularly ED25519, requires a lot of 256-bit multipliers. And those can be very difficult to do on a 32-bit RISC-V core. So we offload it to a DSP that Bunny ended up designing. I emulated this in Renode as a peripheral so we can run the engine's firmware as if it were running on real hardware. And we checked this in, and somebody checked it out. This person named Fabian Weisberg checked it out and added these vectors from Google Project Whiteproof, which basically tests the engine a little bit better than we had done. It's additional test vectors that we didn't test before. He checked them in, ran it under Renode, they passed, submitted the pull request, and then they got added to the repository. Now the amazing thing is Bunny checked them out himself, built them on hardware, and discovered a bug. It turns out that his implementation didn't properly propagate the 17th bit. So he was failing on some of the tests that ended up passing in Renode. And because this person from managed to add these test vectors, we were able to catch them. Now, if you look at the date here, 7th September 2021, it is now 9th April 2022. We just got users real hardware 3 weeks ago. This is months ago that this person managed to download the software and find this bug and contribute to the project. So again, emulation brings more eyes to the project because it's easier to download software. Renode also supports robot framework, and this is where the CI part of the talk title, the original talk title, comes from. If you're familiar with robot, this should look very familiar. If you're familiar with COBOL, this might look familiar as well. But robot is a common test framework that lets you run various test cases in CI. This is actually from Renode's built-in test cases. The way robot works is you have sections. This is the settings section. Most of this is going to be the same across all of the tests you see. It just says how to set up the particular test case. Then you have the variables section. That is all the variables that are used with all the tests. In particular here, you could see we're actually defining a REPL file, a Renode platform file here, where we're using the recursion feature, where we're actually just saying, yeah, this device under test, it's just a Nordic NRF 52840 core, which is a very standard Bluetooth core that comes built in with Renode. And what we're going to do is we're going to add this accelerometer, this LIS2DS12, which is the device we're interested in testing. We're going to add it on the TWI1, that is the two-wire interface, otherwise known as I2C, bus at address 1C. And we're going to hook this accelerometer's sensor up to GPIO 0, port 28. So this is something that might vary from board to board, which GPIO port it's connected to, which address it is, which I2C device it's connected to. But you can see it's very easy to change that just in this one text file. Down below we have the keyword section, which is essentially functions that can be called by test cases. In this case, we have a keyword that creates a new machine for testing. So you can create a machine very easily, just say mock create. You load the platform definition from what we defined it up above as a string, and then you load an ELF file. And finally, we test to make sure that it can read the acceleration. We're actually calling C# functions on the accelerometer. So acceleration X is a C function that is defined on the accelerometer chip. And then we start the emulation and make sure that the UART prints out the correct values. You can actually see we're also testing the rounding of this particular C library just to make sure that it hasn't changed, possibly due to a new version of libc. This also means you can throw this into GitHub Actions and test your firmware every time you push code, just as you would test any other desktop application. Renode is also useful for reverse engineering. There's other things you could do. For example, there's this standard called SVD, which is an XML file that most chip vendors have that describes the chip. It's essentially an XML version of the reference manual, except everybody follows the same standard. So it starts out with the vendors section with things like the name of the chip. Down below, we have things like the peripherals. So you can see here, this is the random number generator of the blue NRG. You have the name here, description, which isn't always very useful. But more importantly, we have the base address for this peripheral. So we can use this to assign information to the system that's being emulated. We also have the individual registers, including their name, the offset. So in case of the UART, this would be DR, address offset 0. We have the different fields here. This is actually really interesting because within a single register, remember there was that individual registers section we saw in the reference manual, we also get individual bits here as well. But crucially, we also have the reset value. So the SVD will tell you when the chip starts up, what is the default value? And this becomes particularly interesting for chips that have version information and software that looks for that version information to determine which version of the chip is running on. So that will have a reset value that depends on the exact version of the chip you have, that we can actually pass this into Renode. We can apply this SVD file to our sysbus, which means that when you run your code, if there's a register that's unimplemented, Renode can now log which block, which register, and which peripheral it's reading and writing from. For example, the first one on the screen, it's trying to read from the data register on GPIO. If you didn't have that, you would just say 4000, and you'd have to look in the register manual manually. Here, you can just let Renode take care of it for you and relabel everything. And you can see the last read on the screen there from clockgen_BLE. It's filled in the default value for us, which probably means something like clock was reset due to system start, I'm guessing. You can also load an ELF file and have it log function names so as it executes various functions. So this is an example of logging function calls on the embedded controller for Betrusted. Because Betrusted was loaded from a bin file from an SPI flash, I didn't have functions on there. So I just loaded symbols from an ELF file and started logging. And you can see it entering the function. It tries to join the Wi-Fi, then it tries to configure IPv4, and then it requests a DHCP address. Also cool is that this is actually Rust code that it's running. So it doesn't matter that it's Rust, it's going to still print out the function names that it gets from the ELF file. If that wasn't enough, you can also debug the emulated system with GDB. Just say machine start GDB server, give it a port number, and attach GDB to it. Specify the port, and you can start disassembling code right away. You can disassemble from the program counter on. You can print the registers. You can examine memory. It works pretty well. Notice I started GDB here without symbols because for this particular device I didn't have symbols. What you can do is you can just create an ELF file. This is probably a whole nother talk in itself, but you can actually feed binary files into this lovely software called Ghidra that has a really nice decompiler. You can label, you can rename functions to give function names that make sense to you. Then you can generate an ELF file and load those into both Renode and GDB to make debugging on the device that you're testing much more understandable. We've also got multi-system emulation. This is what we would do with Betrusted, where we actually have two different chips that are running in lockstep. One of them is 10 times as fast as the other. There's the EC on one side that's connected to Wi-Fi. There's the SoC that's on the other that's connected to things like the keyboard and the display. And they communicate over a COM bus. And so we can actually run all of these in lockstep together and get a whole system emulated. Running short on time, but there's some other fun things that Renode can do. You can load peripherals at runtime. You don't actually need a C compiler or a C# compiler. It'll load C# files natively. So this is just me including a C# file, and Renode will take that, compile it, and give me access to that peripheral at runtime. And these peripherals are cross-platform, so you don't need to recompile Renode for Windows, Mac, or Linux. You just include your C# file with your distribution, include it this way, and you should be able to add it as a peripheral on your device. Peripherals are also relatively easy to create. Remember, I said he created a display in an hour. That's not unreasonable at all. When you create a peripheral at runtime, you would do something like this. You have an enum with all the registers that comes straight from the reference manual. Then you have this function called define registers. This is an example of something that has 2 bits. We define each bit differently because doing bit shifts is really hard and is prone for error. So we say bit number 0 is a callback closure that just returns true, because in this case, this is a random number generator, and because we're emulating this, we can lie and say that we always have random numbers. The second bit here is whether or not the random number generator has available data. Again, we're just going to lie here and return the bit true. The flag feature makes it very easy because, again, you don't have to worry about bit shifts. The data field on this particular random number generator is not a flag, it is a value. In fact, I make it a 32-bit value, and I pass it the function value provider callback, which is, again, a C# closure. And I just use the system random number generator because it's C# is the full language that comes with things like a random number generator. So this is the entirety of the random number generator implementation, plus a little bit more glue to add this as a C# class. You can load this into your running emulated system at runtime. It'll compile it, and then you can use it in your target system. This is C# to answer the question. You can also, because Microsoft created C#, they also created Visual Studio Code. You don't need to get a full Visual Studio install. You can actually use Visual Studio Code and get autocomplete with the C# because the Renode binary itself contains a lot of debug symbol information. You can just point Visual Studio at Renode, and it will give you all of the library information that Renode uses. For example, here I'm doing autocomplete on what a double word register value looks like, and you can see that there's a function called change callback that takes 2 arguments. This makes it really nice for debugging new peripherals because if the IDE says that your code is good, it's going to run the first time. It may not make sense logically, but they'll at least be free of syntax errors, and you get autocomplete, which is huge. You could also do networking with TAP. Now, TAP is a device for doing adding virtual network devices that you can use to bridge to your Ethernet device. Started at Linux in 2000. It's been ported to Windows, and there's a version on the Mac. You can create an emulated switch using this command. You can create a tap on your system using this command. And what this will do is this will create a new network interface or Ethernet device on your system, which you can then bridge or run NAT on or whatever. And then you can connect the host system that is running Renode to an Ethernet device that your device under test may have. If you don't want to connect it to your host system using TAP, you can also connect it to a small network that is entirely emulated. An earlier version of this just had me emulating a Linux system running on ARM that was providing DHCP information. But with this, you can actually get your emulated system working on the internet to the point where you can actually send and receive pings. You can do everything you would in a real system running on your desktop. So the bottom line, Renode is free software. It's MIT licensed. Give it a try. I think it's underappreciated. I think more people need to know about it because it's really cool stuff. It's really good, really easy to make new peripherals. And thank you for joining. So Put some links up here. There's Reno.io, which is the software that we've been running. Betrusted.io, which is the which is the secure communications device. There's the link again to this talk if you'd like to see it after the fact. The source to this talk is also up on that Git page if you'd like to download that. That's all. Any questions?
Okay, thank you very much. Yeah, that was just so deep. Like I already get a lot of feedback from people, and we have time for one question. This from Nilek, and he says it's partly a philosophical question. Can an emulator be better than the original hardware, or is the original device per definition the best solution? How about fixing bugs of the original hardware?
Oh, that is a great question. Again, it really comes back to what your goals are. If your goal is to, for example, with a Nintendo, nothing can emulate the feeling that you get when you're 8 years old playing with a game on Christmas morning. There's nothing that can come close to that. But it is a lot harder to attach debug probes to a real Nintendo system. So it depends on what you're looking to do. For a lot of what we want to do in terms of development, an emulator can be better than the real system. A practical example is that a Cortex M0 usually comes with 2 flash patch points, which let you insert breakpoints on read-only flash. As soon as you exceed 2, GDB will throw lots of fits saying you can't continue because it can't add breakpoints. And this happens a lot when you have code that's been heavily inlined. So a single line of code might equal 20 different lines in the flash file if it's a particularly hot function. Things like locking, disabling interrupts. That's generally a single function that gets lined everywhere. So if you try to insert a breakpoint on that, you'll hit 30 breakpoints and your system will refuse to run. With an emulator, that's no problem because Flash is emulated, so you can insert as many breakpoints as you want. So if you're developing, emulators possibly are better, especially when the hardware is still changing. But nothing beats the real thing. So we do have real hardware that is connected to a Jenkins machine with Betrusted that is running all of these tests on real hardware. But because we have access to the cloud, we can now run 5, 10, 15, infinite number of emulated systems in the cloud, which scales a lot better than just the 1 or 2 devices we have connected to hardware here in Singapore.
Okay, thank you, Sean. It's been an absolute pleasure having you here again at the FOSSASIA Summit, and I hope we can catch up sometime soon, in person, right?
Definitely,
okay.
Looking forward to that. Thank you for having me.
Have a good evening. Thank you very much. Bye-bye. Okay, so I'm handing over to Mr. Mishari, and Mishari Mukbil, I think you're still in Thailand, and it's very late over there in Bangkok, right?
It's all right. It's 7:40, not too late, not yet anyway. All right.
Okay, and so how's the weather? Is it very warm?
We only have hot here in Thailand, right? Hot and smoky.
Okay, hot and smoky. So back to the normal way things are in Bangkok, but let's work on the future. Let's get things better here with open hardware. And I'm handing over to you now. Thank you very much for taking over the moderation.
Here's Mario. Good evening, everyone. As Mario said, I am Mishari Mukul. I'm based in Bangkok, Thailand, and I will be your MC moderator for the evening. Next up, we are going to have Mahera Hassan from Technische Universität Berlin, a researcher who will be speaking about OpenNext, establishing company-community collaboration for open hardware. Mahera, hello. You need to hit the headphone button at the bottom of the screen. Is it working? You are muted.
Sorry, I hope you can hear me now.
I can hear you now.
Very well.
All right. Well, over to you.
I will try to share my screen.
Yes. In the meantime, just a reminder, questions in the shared notes, please. And if you ask a question, there is a chance you will be selected to win one of 100 t-shirts.
I would be needing support here.
Sure.
Regarding, this is my first time regarding the share of the screen. Okay, it appears now. Yes, so I will directly share my screen. I hope you could see my presentation.
It's working. Would you like to full screen it before I, yes.
How about
Perfect.
now? Okay.
Yes, excellent.
Yeah, so thank you very much for having me. My name is Mihira Hassan. I am a research associate at the Institute of Machine Tools and Factory Management here at the Technical University in Berlin. And we are also the coordinator of a Horizon 2020 project called OpenNext that tries to develop a collaboration or strategic collaborations between companies and open hardware community members to be able to develop and product and services in an open source hardware. So before going ahead and introducing the project or OpenNext itself, I would like to start by a vision that we all share together here as within the project, which is that the future is definitely going to be open, and the product creation is not going to happen within the company, but it's going to happen within a community setup. So today, the industrial product creation or today industrial product creation is still very risky, it's expensive, and also it's super not super sustainable. So and this could be a direct consequences of how we develop product and of how we develop product nowadays. So there is a lot of over engineering, a lot of planned obsolescence, and also there is a lot of lack of inclusivity. So still today, development, designing, and producing of products is happening behind company walls. It's IP protected, and it's also super far away from the main users of those products. So it's developed in the company, and the users are way far away from the development or the design process. On the other hand, thanks to the open source movement and also to access to technology, users and community members does not want to sit and receive products anyway, but they have the capability, the ability, and the interest to be to actually be part of this developing process. So the main idea of the product is that now for small and medium-sized enterprise, there is a big opportunity to just stop developing products and services indoors and moving ahead to join forces with all the great community members working there on open source and dissolve this company walls and move ahead to a strategic collaboration that would benefit everybody, which is what we call company community collaboration that we in OpenNext are trying to crystallize. So a few words to the project itself. So OpenNext, it's a research project funded under the European Union Research and Innovation Program as part of Horizon 2020. And it's basically covering a call called Factories of the Future. It's how product and services is going to be developed in the future. And the project itself bring together 19 different partners from 7 European countries. We're talking here research institutes and university plus also a lot of great enterprises, platform providers, and maker spaces, plus SMEs who joined us together to be able to realize this vision of how this collaboration between companies and community could then influence the way we design, produce, and also distribute the products in the future. The project is 3 years. It started in September 2019, and we're continuing now at the final stage of the project, moving ahead to November this year. So how we talk about a collaboration between companies and also open source hardware communities, but how is the whole setup then done, or how is the whole vision? So the main idea is that we wanted to bring companies and then support them unleash the potential of open source hardware. How to do that? By working together in product development, together with Fab Labs and community members. So all these three major players here, the companies, the Fab Lab, and the community members. Community could be community of users, of individuals, and also could be the community of the company themselves. So we were trying to create what we call an open source development ecosystem, where those players would come together, and then we would look how could this the development of products happening and how we could facilitate that. So OpenNext is trying to see what are the needed components that needs to be established in order for this to happen. So we are looking into the needed ICT infrastructure for certain collaboration. What kind of business models then would make sense, because companies would be scared if we talk about open source hardware as a way, as a strategic way to make a business, but actually this is possible. So we're researching into business models and facilitating of that as a viable way to produce products and services. Prototyping facilities, how maker spaces could join in and help facilitating a place where this community members and company could come together to do physical prototypes of these products and services. And then, of course, to support all that going on, there would be other aspects like, for example, collaboration design processes, licensing, the topic of licensing, the topic of documentation, as it's but could you still see my
Your
presentation?
webcam. No.
That's quite problematic. Let me. I will try to reshare.
Please do.
How about now?
Yes, you're back. Thank you.
Oh, right. Sorry for the interruption. And then after those cases were studied and the results were concluded, we have expanded since the beginning of this year by adding another cluster in Vienna. And to validate the findings and of this phase, we have started in January by inviting new 12 SMEs to join OpenNext 4 clusters in order to see if all the tools and all the methods that has been developed can be validated through this phase. So we started now going from January to June with 12 interesting SMEs that are going on now hard and strong. So in this part of the presentation, I would just also want to talk a bit about what is the type of project that has been developed within each cluster. So starting with the Berlin clusters, the prototypes for Europe, who are also with us in this session, has helped 2 companies. I will start with Sono Motors. Sono Motors is a self-charging electric car developed by a German company here in Germany. And the main idea, they partnered with us because they wanted to work with their own community in personalized those cars. So they want community members to come in and then design specific personalized item within the car. This was done together with prototypes, where an open call was open. Community members shared their design. They were invited to come into Sono Motors to prototypes, and 6 interesting prototypes emerged from that. Also, prototypes has helped the Pocket Science Lab from Eventyay to be able to move from a nerdy product to a product that could be actually commercialized. The 3 upcoming sessions are going to talk a lot more about how this collaboration with the community member of FOSSASIA, I would say, has emerged through the OpenNext, and I'll also be around for that. Moving on to the next cluster. The WAG Society also had 2 very interesting cases of Sodak, which is an IoT company who was interested in developing an air quality sensor for the city of Amsterdam, but wanted to do so together with community members. So the collaboration that targeted community of concern, so people who are actually going later to utilize this sensor to come and work together with the Fab Lab and Sodak in order to discuss what kind of a design would be accepted, what kind of a technology would be accepted. And this is key for such a company to be able to move ahead with the development of a sensors that later on is going to be adopted by this community. On the other hand, Fiction Factory is a very interesting SMEs that wanted to join us in OpenNext to be able to utilize open source, in order to find a sustainable way to deal with their CNC waste machinery. So they wanted to work together with the community and develop open source hardware, different products that could be actually generated or developed out of this waste material. And WAG Society helped moving ahead with that. Moving to the Copenhagen cluster, Maker also had quite an interesting collaboration with XYZ Cargo and Stika. I will share some of the findings. So Stika is a build-to-order furniture company who is committed to the open source movement and believe that open source is not scary. It's actually the way they want to do business. And within OpenNext, they worked at the last desk, which is a design for disassembly desk. And they wanted their community member to design plugins and be able to make modular designs out of your desk. So you get all the documentations of the desk, and then you move ahead as a designer by actually talking about how could you, what are your needs, and then design your own plugins. They opened this call. They are so committed to the open source. They have their own platform for open development with their community of designers. And then they openly share the designs with them. And then also moving ahead, a lot of designs, they did a design competition. A lot of designs came in, and they took it to the next level. And having prototyping sessions within the company, but also within the maker spaces. So the community members were invited in to be able to realize the designs that they want, and then eventually there was a scheme of how could this design then be featured in their website, and how could then the community benefit from specific revenue streams for the design that would be sold. The other interesting case was from XYZ Cargo, which is cargo bikes that the company wanted to develop add-ons to just have different features and different functions for this cargo bus. The company is based in Hamburg. They wanted to be able to just create a community of designer and develop and be fully committed to open source hardware when it comes to the design of add-ons. The way the collaboration went is through an open call. They received 70 different inputs regarding design's contribution. And then this was moved from an online collaboration with the community to a real life collaborations where one-to-one meetings has happened until specific designs were selected for further prototyping. So now, so during the OpenNext, there would be an add-on that will add to the bike that shapes a workshop bike and also a food bike and also a music kind of a bike. The most interesting part of XYZ Cargo is that from the very beginning they believed in the open source movement, and also they believe that there should be a way to pay back the contributors from the community members. And a lot of discussions went into what would be the best way to also pay back, not only once but instantly as this design will be moved forward. So we consider it also a very, very interesting case. As of these cases has happened, the makerspaces gain more competence, and we moved ahead by bringing along 12 new SMEs that started also on their own individual projects from January, and they are continuing on a lot of interesting cases who are looking into build-to-order furniture. Also, interesting community members, like one of the cases is developing or trying to develop a device for blind and visually impaired people to just also on a bigger mission to bring them into maker spaces, developing and 3D printing their own device. A lot of interesting projects in the direction of refrigeration for remote areas. This is also taking place in Maker. We are also making an event end of June that will demonstrate all the 18 cases, including the 12 new cases that are taking place now. And the project will continue. All the findings, the tools are going to be documented as part of the book that will be published later. We're also trying to establish a way for makerspaces to come together to learn from this experience, so that they could be open source developing labs and could help further SMEs take the steps and join see the opportunity in collaborating together with community members and benefiting from and actually contributing and benefiting from the open source movement. To know more about us, check our website, also at our project hub, at our partners website, our partners platform Wikifactory, and we will be publishing information soon about our demonstration day end of June in Berlin, and I hope that you could also join us there. Thank you very much, and I'm open for questions.
Thank you very much, Myra. Unfortunately, we only have time for just one quick question. The question is, well, first of all, can you imagine a world where all product creation is open hardware? And are there certain industrial fields which could lead the way?
Okay, so can we imagine a word that,
Sorry, it's a quick question.
Okay.
Emphasis.
I would say yes. It's not going to happen soon, but I think now, especially micro to small and medium-sized enterprises, has started to see the potential in the open source movement, and eventually this is why we started such a project, so that we would start with companies that are flexible enough, not the big manufacturing companies, but the companies that are flexible enough to try out, to explore and try out things that can contribute to them making it. So we hope that one day this could be realized, but we're taking the first steps in that direction.
Well, thank you. Thank you very much. And thank you so much for trying to stay on time, Mahira. I understand that there's been a bit of pressure, but we really appreciate it. Okay, so next up, we have a talk about a panel on the Pocket Science Lab. So I would like to invite, and I apologize if I mispronounce anything or anyone's name. We have Madhushankar Padmo from who's a PhD student at Uppsala University and who is the hardware lead in the PS Lab project. We have Daniel Maslowski, a software engineer of Hostile Education. In his free time, Daniel works on open source software. He created Frika, the firmware editor. Then we have Marco A. Gutierrez. Sorry, Marco, I still haven't gotten your last name right. But then he's a software engineer at Open Robotics, currently located in Singapore. And we have Mario Billing, the CEO of OpenTech. It requires no other introduction. We have Dr. Daniel Weselek, who is Interaction Design, Open Knowledge Foundation, Deutschland. He is passionate about the intersection of open hardware and open workshops. Daniel Bestman, Electrochemical Systems Engineer, Scania CBAB, who is a hobbyist hacker and Pythonista, lead developer of PS Lab Python. He is also a chemical engineering PhD with a focus on electrochemical modeling, currently working on battery development in the automotive industry. And last but not least, we have Alessandro Volpeto, a biohacker, top lab at Top EV. Alessandro designs innovative tools to support a collaborative research environment and facilitate the learning process in life sciences in and outside of university. Okay, I think we are all here. Thank you very much. So over to you, Mario.
Okay, thank you very much. And I think we are still missing Daniel Weselek. Daniel, I see you are here, so I hope you can join step by step, getting free. But we wanted to start this session with a short introduction. What are the news with the Pocket Science Lab? Like many already know about it, it's this nice little platform for testing and for oscilloscope and a lot of other instruments. And we'll try to share as much as we can in half an hour session, but I can say right away, we would like everyone who's interested to join our weekly meeting and continuous exchange on GitHub. And I hand over to Padmal. Padmal, you wanted to share a bit about the news, and do you have already the presenter rights? I give you the presenter rights, and you can go ahead and share a bit about the latest updates of the Pocket Science.
Now I can. So hello everyone. So with me today we have the whole PS Lab development team with me, and I'll quickly give a short introduction about the project and what we have been doing over the past few years, and then we will have a group discussion. So this small device is a portable handheld device where it has all the devices and instruments you can find in an electronic lab, which is listed here. I'm not going to go in every point. So we started this project as a Google Summer of Code project in 2017, and over the past few years we had many talented developers and people working with the project. So we got the board out in the market, and we didn't stop at that point. We carried on, and we tried to get insight from many talented people in the community, and we try to embed more new features into this board. And so we have a new PS lab that is almost done being developed, which looks more like this board. And what we were doing, improving the device that is on the market, is that we need to make it more cost efficient in production. And so with the help of Raphael, we were introducing smaller, much cheaper but effective chips, and also we were introducing a new operating mode that we call standalone mode, where the PS Lab device, rather than it's being a Pocket Science Lab, it also acts as a data logger. And to facilitate all these things, we've upgraded the firmware as well. So the biggest change is that now we have a bootloader. Earlier, one needs to have a dedicated programmer to upload the firmware, but now one can do it over the USB. And so with this new standalone mode, one can assign a specific task for the device to do, and it will, with the help of an external battery, it will keep on running and keep logging data. And as the next step, we are also not stopping there. We are exploring the possibility of implementing a new chip, rather replacing the current big microcontroller we are having. It could be a powerful ARM processor, or it could be an FPGA. If we are in the process of research. And then I'm opening the floor to my group.
Okay, perfect. So my idea was this: we have half an hour for this session, and of course it's never enough. But I thought maybe we can give people insight a bit what we are working on, what we are collaborating on, and what are the current topics. And it would be great if everyone could just share a bit about their ideas. Why are they motivated to work on this project? What's their interest, and what would they like to see happening in the future? And yeah, I just nominate first Alex.
Thank you. Can you hear me okay?
Yeah.
Okay, very good. Yeah, so what I've been working on recently is actually the topic of the next session. So I won't go into it too deeply in order to not spoil anything, but it's really about integrating a sensor, writing a sensor driver for a specific sensor, which we want to use in Alessandro's project, the open spectrometer. So that's been a very interesting project. Quite challenging at times, but we got it working eventually. Beyond that, there's also the whole firmware refactorization, which we have been working on for the past year or so, which is basically we're rewriting the firmware for the PS Lab from the ground up, more or less, for the next version of the hardware. So it's the firmware code is a lot more readable now than it was in the old version. So that's very helpful if someone wants to get into development and help us out with something or add their own features. And of course, PS Lab Python, that's hasn't seen so much activity over the past year since the refactorization of that library finished. But it's progressing. Now it's time to start modifying that to support the new hardware, and I guess that will be the work of the next few months. And then I nominate Orange CMS.
Yeah, that would be me. Yeah, hello everyone. I'm Daniel, and I work mainly on the PS Lab desktop application, but I also call myself a full stack developer in a sense. I also work with lots of different microcontrollers and also other SoCs in the processor space that can be x86 or RISC-V application processors and so on. And I prefer to look at the entirety of the stack. So With the desktop application, we're sitting very much on top of everything else. So we also need to rely on everything else. And naturally, that also means that, if anything goes wrong somewhere else, the problem is on us, sort of. And yeah, I will also give a talk on that later on. And I will tell a bit more about how all the pieces are actually put together to get the final desktop application, which we're currently shipping as an Electron app. So it's essentially a Chrome browser running as the front end, and then talking to the Python library that Alex is working on, and below that, everything else until it makes it to the hardware. And so what I've been doing over the last month, and actually a bit more than a year now, was to do some research on how we could make the integration a bit more smooth, various options to explore. And yeah, that's already a teaser for the talk later. And with that, I hand over to Marco.
Hello, everyone. So on my side, on this, which is a version of the Stanford Puppet. This is gonna probably run with a Raspberry Pi, but I'm sure like we can integrate some PS Lab into it to delegate some sensor operations, and probably do some cool stuff with it. Yeah, so that's mostly it on my side, and can't wait for the new version of PS Labs to work on more. So I'll nominate next the other Daniel Vasilek.
Yeah, cool. Thank you. Nice to see the new robot. I hadn't. Whereas with other, because there was a question in the chat, what's the Arduino, what's the Raspberry Pi, what are the differences? And for me, one big difference is that on the PS Lab, there is already the firmware, so everything is already working. And if you don't know how to solve it, then you don't need to change in the firmware things and so on. But you can stick to the Python script that you're running, and makes debugging much easier. So from my experience, it's really nice to use this, and I'm also trying a little bit to take the user perspective in this project. And I hand over Mario.
Yeah, so actually I have to say we don't have everyone here in this session. Also try to get Raphael here from Shenzhen and a few other people, but yeah, it's not always possible for everyone to join. Don't know how's the situation in Shenzhen now. Maybe people have heard things are really like locked down as well, so I can't reach him right now. But what we want to share with you guys out there is like a lot of cool stuff is going on here. I don't see Alessandro anymore, but Alessandro, I will show what you are inspired here, the team to do and to work on, which is
whatever. So we have open source hardware, and everybody know what it is. Open source software, pretty clear at FOSSASIA. We call it, but we have something else in biology, which we call open source wetware. What is wetware? So living beings, how do we open source an organism? And yeah, this is the main question that I'm dealing with. And I collaborate with open source hardware and software and FOSSASIA and the Pocket Science Lab because I want to integrate this concept of having open source in life sciences. Okay, what does this mean? What are the opportunities of that? I will be really quick. What I'm doing now is to cultivate mushroom to build alternative materials for the future. So we want to replicate, to replace plastic, for example, and so we need new materials. And so we fabricate these bricks out of mushrooms, we grow them, and we can build a house with them. You see how easy it is to build with mushrooms. And yes, I went, so what I do in my practice to facilitate this is I teach people how to grow these materials with open source or accessible tools and do the same that you do with open source hardware and software. I was 1.5 months in Sri Lanka, now in Batticaloa, and told people about how to do that. I want to replicate this also with Pocket Science Lab and with the spectrometer project. What can we do with a spectrometer? A spectrometer is a device which is used in the biology labs to check what's in your sample, what's in a liquid sample, for example, in the water, in a water sample, or if you extract some chemicals from a mushroom, from a plant, you want to check exactly what you extracted. So for example, a medicinal compound, and how much of it you have to make a medicine. So if you want to make a drug. And this is why I want to implement an open source spectrometer, to allow people to develop tools to produce own, let's say, medicinal compounds, or at least to learn how to, and then join the pharma industry, or also to study their environment, if there are any pollutants, how to measure them, and how to check if what you are eating is safe, or if, well, which kind of nutritional properties your food does have. Yeah, and basically that's it. But it's in the setup we are doing it, it's more a learning tool, but we want to set up the hardware development to hit a very high standard and to try to go for really high quality, lab quality devices. Okay, that's it, I guess.
Yes, and so I think we made a lot of people like interested in the project, and hope you guys share, check it out on pslab.io. And there will be some sessions now upcoming here. And the next one is with Alex. So I would say thank you very much, everyone, for this introduction. Great to get together. And let's continue what we're working on. A lot of interesting things lie ahead of us. And thanks, everyone, for watching here our quick get-together section. So let's continue, and back to Mishari.
Leave your questions in the chat notes. That'll be appreciated. All righty, let's get this video on.
Okay, let's do this. Welcome to this talk. I'm Alexander. I'm one of the developers of the Pocket Science Lab, or PS Lab for short. as well as the main developer of the PS Labs Python API. In this talk, I will first briefly introduce the main instruments of the PS Lab, give some examples of the types of sensors which can be implemented in Python by combining these instruments, and then we will move on to the meat of the presentation, which is a demonstration of how to write a driver for a specific sensor, the TCD1304 linear CCD. And we will do this by coding clock drivers to drive the sensor, and as well as a method to capture the sensor's analog output. Okay, so the PS Lab, you can think of it as a Swiss Army knife of some common scientific instruments. It has, among other things, an oscilloscope, which can capture analog time series data, a multimeter, which can measure simple voltages, of course, but also the properties of some common electrical components, such as resistors and capacitors. It has a logic analyzer, which can record digital time series data. And I should mention that both the oscilloscope and the logic analyzer can do this on up to 4 channels, and up to about 2 megahertz, 2 megasamples per second. Even a bit higher than that for the logic analyzer, I think. And then it has a waveform generator with which we can output or generate analog waveforms, like sinusoids, for example, up to 5 kilohertz on 2 channels. It has a PWM generator, which can generate digital waveforms, or PWM signals, I guess, on up to 4 channels, up to 10 megahertz, as well as a power source, which can generate adjustable voltages between -5 and 5 volts, and adjustable currents between 0 and 3 milliamps. And those are the basic instruments of the PS Lab. It also has some other stuff, including serial buses, which we will not cover today. Okay, so by combining these instruments in different ways, we can write drivers for many types of sensors, including the list here you can see, as well as others. Many sensors output analog signals, and those can be measured with either the oscilloscope or the multimeter, depending on how fast the measurement needs to be. Many sensors also require some type of pulse to trigger it to do something, like start the measurement. For that, the PWM generator comes in handy. An example of a sensor that uses more than one instrument are ultrasonic distance sensors. The PS Labs Python library contains a driver for that type of sensor, which works by emitting an audio pulse when it is triggered. The audio pulse then bounces off whatever object is in front of the sensor, returns an echo, and that echo is detected by the sensor, which then raises a digital output and holds it high for the length of time it took the echo to reach the sensor. So the PS Lab implementation of this is to use the PWM generator to generate the trigger pulse with the logic analyzer to measure the length of the echo pulse. And with that information, we can calculate the distance to the object in front of the sensor using the speed of sound. Okay, so today the sensor of interest is the TCD1304 linear CCD. So a linear CCD, you can think of it as a type of one-dimensional camera. It has a bunch of pixels in a line. In the case of the TCD1304, they are basically black and white. They output a voltage value,
which is proportional to the amount of light hitting the sensor, or hitting that pixel, rather. It has 3,648 pixels in total, as well as 48 dummy pixels, which are a kind of buffer, I guess you could say. It outputs the values of those dummy pixels, but they're only there for in order to show us where the measurement starts and ends, basically. This sensor is driven by 3 separate clock lines. The master clock, which runs at between 800 kilohertz up to 4 megahertz. The integration clear gate, or ICG, which runs at 1/4 of the master clock divided by the number of pixels, so 3,696. And the shift gate, SH. The SH clock runs at either the same frequency as the ICG or faster than the ICG in something called electronic shutter mode, which we're not going to implement today. So for the purposes of this talk, the ICG and SH clocks run at the same frequency. And then the sensor outputs an analog signal, as I mentioned, and it does this at a data rate which is equal to 1/4 of the master clock. So effectively 1 pixel per 4 periods of the master clock. And today we are going to write a driver for this sensor. And the final instrument, the final sensor driver will use the PWM generator to generate or to drive the 3 clock lines, as well as an oscilloscope to capture the analog output. During development, we will also use the logic analyzer to make sure that our clock lines are synchronized properly. So let's get coding. First of all, let's take a look at the actual timing requirements of this sensor, which are quite precise, it turns out. So here you can see the SH and ICG clock lines. As you can see, the SH line is typically, it's normally low, and the opposite is true for ICG, it's normally high. And in order to get the sensor to output its pixel values, first the ICG line must go low, followed by the SH line going high within 1,000 nanoseconds of the ICG line going low, but no sooner than 100 nanoseconds. Then the SH line should remain high for at least 1,000 nanoseconds, after which it goes low, and after it has gone low, the ICG line should remain low for another 1,000 nanoseconds at least. And then there is a fourth criterion here, which is actually wrong, so we're not going to talk about that. So let's move on to some coding. So let's create a class called TCD1304, which will be our sensor driver. The first thing we're going to need is a connection to the Pocket Science Lab board. For that, we are going to use the serial handler class from the serial handler module of the PSLab Python library. We are also going to need the PWM generator class. Let us create a method called startClocks. This is what is going to run our 3 clock lines. First of all, master clock. Master clock has high frequency and is therefore suitable for the map reference clock method, which outputs the PSLab's internal oscillator to an output pin with a prescaler. So effectively, this means 128 megahertz, which is the frequency of the oscillator, divided by 1 bit shifted 6 times, in our case, to the left, which is equal to 2 megahertz. That's the master clock. Next, the SH and ICG clocks, which we are going to place on pins SQ2 and SQ3. Their frequency is going to be 125 hertz, because that turns out to be convenient for a number of reasons, which I'm not going to cover here. I don't have time for that. The duty cycles. This is where it gets interesting. So in order to fulfill the timing requirements we discussed earlier, the SH line should stay high for 1 microsecond. And if we divide 1 microsecond divided by the frequency, or rather by the period, so the frequency divided by inverse of the frequency, then that should be the correct duty cycle. The ICG clock line should be it's normally high, so it should be low for a little bit longer than the SH line is high. So let's make it 1 minus, because it's normally high, 2.5 microseconds. Like that, and then we also need to shift, we need to shift the relative positions of these lines relative to each other so that they coincide. And we're going to do that by shifting the SH line a little bit backwards, 2.5 microseconds, let's say. There we go. That should do it. Those are our clocks. Now we're just gonna need to look at them. First, create our device connection. We create our sensor object. We need to import the logic analyzer class in order to see what we're doing. We create that using the same device connection. Then we start the clocks and capture the output. We are going to capture on 2 channels, and we are going to only capture 2 events. That's all we need. We need to convert these events to something we can look at using, for example, matplotlib. And we're going to need to import matplotlib. That should basically be it. So let's see, we need to connect the SH line to the digital input of the logic analyzer, and the same for the ICG line, which I have done. And with that, this is what that looks like. So let's zoom in a bit. So we can see that the ICG clock line goes low at can see the time values in microseconds up here in the right corner. It goes low at 4.7 microseconds, and then the SH clock goes high at 5.1. That's about 400 nanoseconds, which is perfectly fine. The SH line stays high for pretty much exactly 1000 nanoseconds, ideal. And then the ICG line stays low for an additional 1200 or 1300 nanoseconds or so, all of which is perfectly fine. This meets the timing requirements. Excellent. Yeah, and with that, let's move on to analog input capture. Oops, here we go. This is where we want to be. Right, okay, so each pixel value, like I mentioned earlier, corresponds to a voltage, or it gets assigned a voltage value which corresponds to the amount of light hitting that pixel. So we are going to use the oscilloscope to capture that. So we no longer need the logic analyzer. Let's remove that. We are going to create a read method, simple as that. And it is simply going to return. Right, we have to actually import the oscilloscope as well. We need to create an oscilloscope object here. It's going to return the what the oscilloscope captures pretty much. You're going to capture on channel 3. You're going to capture 4,000 samples. We are going to capture those samples with a time gap of 2 microseconds. And let's just see what that looks like showing. So my equals TCD read. Like that. And now I have to actually connect the device to the board. So if you give me a second, I'm going to do that. Let's see. So if I connected everything correctly, this should work. Yeah, looks pretty good. I should mention that I have placed this piece of cardboard, which has a hole in it, in front of the sensor. So that's what you're seeing here. Basically, the entire sensor is covered by cardboard, except for a few pixels here in the middle. So those are more exposed than the others. So this looks pretty nice, really. But the question here is, where does the data start? Where does it end? So we are capturing exactly one period, 8,000 microseconds. But which data, which voltage value corresponds to which pixel? Are we actually capturing one period, or are we capturing parts of 2 periods? Most likely we are capturing parts of 2 periods, because we are not currently syncing the oscilloscope with the clock lines. So we are going to do that by adding a trigger condition to this capture call. So we're going to trigger when a certain value crosses 3 volts, and this value is going to live at channel 2. So what I'm going to do now is I'm going to connect the ICG line to channel 2. So when the ICG line crosses 3 volts, capture will start. So if you recall, the ICG line is what actually controls when the analog output starts. So this should synchronize the sensor output with the oscilloscope capture. Let's see what that looks like. Okay, perfect. So here we can see that something is happening here. This is most likely some kind of noise from the clock line. And here we can see that we are getting exactly 1 period of data. Very nice. I'm going to, let's take a look at that like a few times so that we can see what that looks like when we move the cardboard back and forth across the sensor. So this should give us, yes, exactly. So here we have an updating graph, and you can see that now I am moving the piece of cardboard back and forth across the sensor. And you can see that, yeah, which pixel gets exposed to more light. And that's basically it. We're done for this presentation. I would say that the main takeaway should be that we did all of this in less than 50 lines of code, 50 lines of Python code. If you look at other drivers for this sensor for other microcontrollers, those will be written in C, of course. Those drivers will be a lot longer than this because you have to do all of the heavy lifting yourself. With the PSLab and the Python library, you don't need to mess with C, basically. You don't need to mess with hardware registers. The PSLab does all of the heavy lifting for you, or most of it at least. So we can get away with writing rather little code and still getting quite nice results like this. Okay, so with that, this talk is or this video is done at least, and let's move on to the live Q&A session. Thanks for watching.
Thank you very much. That was certainly a very interesting talk. Alexander, would you like to open your webcam and perhaps answer a couple of questions?
Absolutely.
Okay, so in the share notes, we have 2 questions. The first one is, could I power it with a USB charger obtainable from a hardware store? This is by Anandan Datta. My apologies if I got mispronounced that.
Yes, you can power the PSLab with a USB charger. The problem at the moment is that if you do that, there is no way for you to get any data from the device because the data also travels across the same USB connection as the power typically does. However, as Padmal mentioned during the previous session, we are working on implementing a standalone mode where you could, for example, store data on an SD card. And when that's ready, yes, then you will be able to power it from, for example, a USB charger or any other power source, suitable power source.
Thank you. And the next question by Anon is, what is the limitation for the number of sensors?
The limitation for the number of sensors depends on the type of sensor, of course. If the sensor uses the PSLab's main instruments, which I presented earlier during the video, the oscilloscope, the logic analyzer, the waveform generators, and so on, the limitation is basically that you can have one sensor per instrument, pretty much. Otherwise, you will need to do some kind of external muxing of the signals. There's also some limitation on which instruments can be used together. For example, you cannot use the oscilloscope and the logic analyzer simultaneously. They use the same underlying hardware resources. So that the answer to that question, it really depends on what sensors we're talking about. And if you're using the serial buses, I2C, SPI, then you can have many sensors, as many as the buses support, basically.
Okay, wonderful. Well, that concludes the question. Thank you again, Alexander.
Thank you.
And next up, we have a talk with an interesting title of PSLab Desktop Goes Native, Goes Web. by Daniel Maslowski from Hostile Education.
Yeah. Hi. Could you give me the rights to upload the slides here?
I will give you presenter rights. Just give me a moment.
Mm-hmm.
There we go.
Thank you. Yeah, it'll take a few seconds.
Sure. Is that a Debian umbrella that you have behind you?
Yes, it is. Unfortunately, it's not very windproof, so that's where it ended up here.
Fair enough. Well, at some points, maybe we need open source umbrellas. It feels like something where we should be able to improve on the design and have it commoditized.
Okay, excellent. Slides
wonderful.
are up.
You're on. Thank you.
Okay, so let me quickly arrange things a bit here. So yeah, I'm Daniel. I'm working on the PS Lab desktop application, and today I'm going to talk a bit about some potential that we have to bring the application forward a bit in a few directions. Yeah, first I will give a brief introduction into the project from like a slightly different perspective again. So we already had a few previous talks now, but that's also a good recap for people watching the recording, like standalone. I will introduce a few potential targets for porting the application. One is integrating with SIGROC, more on that later. The other one is on the web, and I will first of all give a bit of an introduction to the web as a platform and where we are right now, what we can do. And then I will showcase a few things, or rather describe a few things that we can already do. And so just very briefly on me, I have a few backgrounds in both IT security and computer science, but as my main profession, I'm now working as a software engineer. So yeah, I approach software from many different directions. And one of them is looking at projects at large, which is also why I'm looking at the PS Lab project from a slight different angle than one specific use case or one specific component that we have. In the open source space, I work on many different things, both in hardware and firmware, but also on high-level things like operating systems and software distributions, or even sometimes systems programming. And I created an application which is called Fietka. It's a firmware editor. And I will also briefly mention that later on, because it also runs on a web platform. So the PS Lab project, as you might have heard already in the previous talks, has already quite some history behind it. It's, well, essentially the hardware itself, it's just a very tiny board. I also have it here. This is one of the earlier versions. So it has a bunch of attachments that you can do. You can plug in instruments, you can use sensors, or you can use its features directly, like, for example, voltage measuring or something like that. That's something you can do for experimentation. But as Alex has shown in the previous talk, you can also do it for active development, like the oscilloscope can be very handy at times, or also the logic analyzer. Yeah, so those are the main features. One thing that Padma already mentioned in the previous talk was being a data logger. So that's a new option that we're working on. And I also gave another brief introduction at Open Up Summit already 2 years ago. The slides are here on that side if you want to look into that. It's not much more than what I'm going to show here today. And so this here is the board itself. That's the PS Lab hardware. If you look at the board, you can probably recognize a few things here, like, for example, the USB connector that we have here on the left. We have the SD card reader, which is a new feature now. We have a coin cell holder for a small battery. And the core piece of the hardware is actually the microcontroller here in the middle. And that's where the PS Lab firmware is running. And now if you want to make use of this board, of course, you need additional software. So we have the Python library that Alex also talked about, and we have a desktop application. We also have an application for mobile phones, for Android, but that's not the topic of today. We will be looking at the desktop application. This is what the desktop application looks like. You see, all the instruments and other features that the board brings mapped into a graphical user interface. So the screenshot is just a part of that. Actually, there is a bit more in the app. You can scroll down and there is more instruments and so on. But what you can do here is you can click on one of those features and then you can explore. You can use them, like the logic analyzer, for example, or the wave generator. Then you can have sliders and buttons and so on. With a wave generator, for example, you could make an LED blink, at different speeds and so on. So, but the application currently it's written in Electron. That's a desktop application tool. And previously it was written in Python, just like the Python library that we have backing everything. But there is a slight little problem with that. Integrating everything, especially the Python library, is always a bit difficult. So we've had issues that people were reporting where they couldn't really get everything to work. And that is essentially because the desktop application, which is running in Electron, needs to call into a Python interpreter and also needs to be able to find the Python library, and that needs to be able to talk to the hardware. So there is quite a bit going on there. I will give some more details on that later on here. And already as a teaser, so one motivation to bring the application a bit forward is that we would like to have a bit more self-containment maybe, so that it's not too cumbersome for people to set up. Like, one issue that was occurring was, for example, that people have their own Python environments, or they did something with Python before. Anaconda, for example, is a Python distribution, and then everything was a bit like hard to anticipate for us. So that always required a bit of support from our side. So one thing that we could do is integrating with Sigrok. Sigrok is also a software project which is talking to hardware. The website is just sigrok.org. And it's mainly for creating like an application that can talk to instruments. So it's very similar to what we're doing with PS Lab, but it has a bit of a slightly different scope, let's say. They want to be cross-platform. That's also one of our goals. So we also want to be able to run on all the different operating systems like Linux, BSD, Illumos, or also Windows or macOS, for example. We can already target a lot of those. And what the Sigrok project is doing, on the other hand, is they have a bit of a stronger focus on, let's say, logic analyzers and oscilloscopes. Now, in the last year, there was already an attempt to bring some features of PS Lab to libsigrok. So the first thing we did, of course, was we forked the project to the FOSSASIA community. So we have it on GitHub now. And then we actually found someone to work on that, and that was Kartikeya. Kartikeya brought support to Sigrok to have the oscilloscope and the pulse width modulation generator. So that's also a tool that you can use in PS Lab. And so we have branches for that now in our fork. And what we could technically do is, first, we can use that in Sigrok's Pulse View app. So Sigrok has this app, which is also a desktop application, similar to ours, just with a slightly different focus. And it can talk to this library called libsigrok, which is then talking to the actual hardware. So it's a bit similar to our stack. What we can also do is we could also build the library or use the library standalone, create bindings on top of that using the Node.js integration that we have in Electron. So Electron is essentially a Chrome web browser, and Node So Node.js environment that is, well, just a JavaScript interpreter, which is attaching to the operating system essentially. And then we can call into that and use the libsigrok library. Then we don't need to do the whole dance over Python. So yeah, that's one thing. But let's look at a different option. So the web as a platform has been growing over the years pretty much. You might have heard about the Chrome OS devices, for example. They're essentially running entirely on the web. And now the question is, how do you actually do that? Because there are many things that we traditionally had on desktop, like Office programs, for example. And now if we want to interact with hardware even, like in our case, it might seem a bit unintuitive. So one project is called WebAssembly. And what WebAssembly is, it's essentially an addition to the application runtime that you already have in the web browser, which is based on JavaScript. So in your web browser, you have a JavaScript runtime. And now with WebAssembly, you have a second runtime. What you can do with WebAssembly is also described on the website. It's a stack-based virtual machine. If you don't understand that, not an issue right now. But what it can do is it can run a binary format that is defined for it, and that can run on any operating system where WebAssembly is available in the web browser. And that's what we already have on Linux, on FreeBSD, on Windows, on all the systems out there, basically. So we could technically hook into that. So yeah, it's designed as a portable compilation target, meaning that what we can now do is we can compile code that is written in C or C++, in Rust or in Go, and run that in WebAssembly. So we could, for example, do that with Sigrok. And I did that in one of my projects, and that's Fjetka, the firmware editor. So Fjetka is an application which is mainly for firmware analysis, but I'm also adding some editing features now. It's a web application. Okay, so currently I'm distributing that also as an Electron application, similar to the PSWeb application. But there is code in there to analyze binaries, which is written in Go. I'm also going to write some Rust code for it at some point and integrate that, but for now it's Go, which means that the Go code is currently being compiled to WebAssembly. And that's how I can now talk from the JavaScript side in Electron to the binary analysis code. And because WebAssembly runs on the web, I can also technically just use everything which is currently running in Electron and put that right in a web browser. So I can put it on a website. Here is an example screenshot from the application. There is a button up here, select file. And if you click that button, you can select a file from your file system. Like it can be some firmware image that you have from, let's say, your laptop, for example. And then you can see what is actually inside of that. And to see what is inside of that, I'm calling into code that is written in Go. And then I get the result back here. And now I can render it in the web browser or in Electron in that case. So that is also something we can technically do with PSLab. But there is still a missing piece because we need to connect to the hardware, right? And that's where Project Fugu comes into play. What is Project Fugu? Project Fugu is about web capabilities, the idea that you can do what you can also do from your operating system directly in your web browser. So it gives you access to, for example, the file system. So you can have a file picker, for example. It can give you access to USB. Can give you access to HID. So HID are human interface devices, and many, many more. And there are two which are, for us, a potential target to use. So there is the Web USB API that I already mentioned. That's been available since the Chrome browser 61. We're currently at version, I think, 100, so that's already long available. We could use that right away. The other feature we could use is Web Serial. So Web Serial is for a specific kind of USB, but not only USB devices. Actually, there are also other serial devices that can be used directly. And that's been available since Chrome 89. So yeah, also since roughly, I don't know, some months. Chrome is running very, very fast, so I'm not actually sure. Anyway, we would need to check whether it's already in the current version of Electron that we can use. And eventually, if you want to look into Project Fugu, there is a tracker on web.app where you can see how far all of the different features are that they have in the project. And you can also see the roadmap. So now, by the beginning of the year, came a post to showcase one example of integrating Web USB, and that was based on Gphoto 2. Gphoto 2, it's a simple application to connect your USB camera and then change settings on it. So like, I don't know, lightness or whatever you can set in the camera, maybe contrast, things like that. Cameras have many, many different options actually that you can use to, get different perceptions of an image or to fix up some, like when the white balance completely went off. It can happen that, you get a completely wrong image, but you can actually correct a lot of things by changing a few settings in the hardware. Now, in order to be able to do that, you need quite a stack. And in this post, there is a description of how this step works. So there is the app running, and behind the app is now a forked version of libgphoto 2, and libgphoto 2 is what gives you access to everything that is in, well, Gphoto 2. And to leverage, well, everything from the hardware, there needed to be a bit more of a stack. So there is one abstraction that is called libtool, and behind that can sit either libUSB or libPTP. Those are libraries to talk to again. And to back libUSB, the author of this fork here also made a fork of libUSB so that it compiles to WebAssembly. If you want to read more on that, I highly recommend to look into this post. But for now, let's just continue and see what we can do with PSLab. So if we want to bring PSLab to the web, first we need to know and understand what the actual stack is. So there is a description of it in the introduction in the docs that we have. And we also drew a bit of a picture. This is how it works. So the blue part here at the top, that's the PSLab hardware. So the hardware is the board itself. So what I also have in my hand right here. On that board, we have the microcontroller. That's where the firmware is running for PSLab. And then we have the USB serial converter. And that's where you now connect a USB cable that runs into your laptop or PC, whatever. So everything that you see in the box down here is now the software running on your PC. So you have your operating system, like Linux, for example, which has a driver for USB and the serial port behind the USB serial converter. So that's how it can already talk to the hardware. Now, in order to drive that, really, we have the Python library for PSLab called PSL. And for PSL to be able to talk to the hardware, there is a library in between called PySerial. So PySerial is essentially a Python library that abstracts away the specific operating system and makes it available to whatever you want to do in Python now. And now, in order to use the Python library, we have a few Python scripts in the Electron application, and that's what the PSLab desktop application is. Now let's have a closer look, because now the desktop application also has its larger stack actually. So we're zooming in a slight little bit. So first of all, we need to talk about inter-process communication. So what we have is, we have the UI, the graphical user interface, that's running in its own process. And actually, I copied this here from our README, so you can also look up and see the entire documentation there. Anyway, so this process, which is now showing the graphical interface, which you saw on the screenshot earlier, with a the red cards with the different instruments that you can pick. It's running in this Electron process, and that's the main entry point for the application. Now we have these Python scripts that we also need to be able to talk to, and for that we have a second process, which is the Python bridge. And that's already where we need to have a strong interface. So we have this background tasks thing here. That's essentially saying we're spawning a Python process, and now we are sending some information to it. So that is what we use JSON for. It's basically just the encoding format, and that way we now communicate back and forth. So that's really just, if you know the idea of Unix and pipes, it's essentially the same thing. It's like a bidirectional communication thing. And now what needs to happen if you want to make it from the graphical user interface down to Python? The first thing is we need to have a handler for the specific action. So if you think like an action like, I don't know, a slider, or it can also be a button, you need to have this thing that then would call another function. We call this a handler. So that picks up the action like clicking a button. Now you know, okay, a button has been clicked. Or you set a value in a slider, now you know the value. What you now do is you call this IPC method. So that is something defined using the Electron mechanisms. This IPC method needs to be defined now for the Electron side. So you can call into that. And now in turn, that needs to talk to the Python process again. So there needs to be another definition of essentially the same thing, but now on the Python side. Now you can already see this seems a bit fragile, and to be honest, it also is. So this can happen during development. You get an error, but you actually need to be able to expose the error in the first place. So this is now a otherwise hidden window where the Python process is being called. That's the second process that the graphical process is talking to. In this case, we're sort of lucky because all that's happening here is that the device cannot be found. So that means we could already talk to Python. We could already talk to the Python library. And the Python library was able to talk to the operating system using PySerial, and it tried to find a device. So yeah, in this case, there was just no device connected. Okay. But what I'm trying to say here is all of these different layers can be very, very cumbersome if there is an error happening there. So what can we do about that? Using WebAssembly and WebUSB, just like with a GPhoto2 use case, we can do the following. We can build libUSB for WebAssembly, just as it's been done for GPhoto2. We can actually reuse the same fork there. Then we can build libsigrok for WebAssembly, which would require some extra effort now, of course, and link that against the libUSB port to WebAssembly. Okay. And now, in order to use all of that, we would need to take the graphical user interface that we have for PS Lab and glue everything together. So essentially, we're replacing the Python bridge, which whatever would be the counterpart here. So this is now a simplified view of what it would look like. So we would call from the PS Lab application directly to libsigrok, and from libsigrok, we would talk to libUSB. Simple enough. But how do we actually do that? So there is also a post that's like the preceding post to the other one, which talks about bringing libUSB to WebUSB. And I also opened a tracking issue in the PS Lab desktop project so that you can look into it and also contribute your ideas. So yeah, how do we actually build libUSB for WebAssembly? The essential part is this. There is a script called AutoGen. AutoGen comes from the GNU Auto Tools, which is essentially, a conglomerate of lots of different tools to, bring a project to different operating systems and, wire it up with libraries that you need and so on. Part of that is also a configure script. And now we're going to wrap that in another tool called emconfigure. EM comes from the mscripton project, which is essentially a C or C++ compiler that can target WebAssembly for you. And there is also one for make. So instead of running make directly, which you would usually do, we run emake and then make. So all that is doing is just, passing down different like environment variables and switches and so on to the underlying scripts. So I did that, and actually I did get some WebAssembly out of that. So you see these files here, a.wasm, that's part of the output, and a.out.wasm. So yeah, I was already quite happy. And what do you do when you're happy, when you made something? You write a tweet about it. So yeah, I mentioned the author of the libUSB fork, our reverser. And yeah, I was so happy that I got that working so far. Yeah, I just had to shout out to the well and see maybe somebody else would also pick this up. And of course, there is now no turning back because, I already connected a bit with another person. And Ingvar, he's the main author behind the libUSB fork and the libg photo 2 work, said, hey, thanks for the shout. He's currently a bit busy with said other things happening. If you look at the flag here, you know what I'm talking about, which I'm not going to get too much into now. But he also gave me a hint on the pull request that is open currently to libUSB to actually support the web target. So yeah, that's the pull request down there. And I picked that up and added that also to the issue that we have in PS Lab Desktop. But now you would say, hang on, what about Python now? So we kind of like kicked out the entire Python thing, but a lot of work has actually been put into Python. And of course, we don't want to throw that away. So first of all, the Python library has a very, very rich interface, right? So on a higher level, you can script very, very easily. Alex just showed you how in, I don't know, 50 lines of Python, you could write an entirely new driver for a new sensor that you would like to use, which is very, very awesome. So porting all of what would be necessary for that to another target would be very, very cumbersome. So that's not really an option for us. One thing we could do is we could use WASM to call into Python from WebAssembly. No, hang on, to call into WebAssembly from Python. So you could, in Python, you could import something that is then calling something from WebAssembly. So in that sense, what we could do is we could take that libUSB port and use that, and then maybe wire it up in a different way than using PySerial. But I don't know, it doesn't really sound right. Yeah, I mean, we could also replace parts of the Python code and, just do the protocol part where we're talking to the PS Lab hardware. But yeah, that's also quite much actually, because, there is a lot of control logic that we have in PS Lab Python. So that also doesn't really sound like an option. So another route we can take is Pyodide. What is Pyodide again? Pyodide is a port of CPython to WebAssembly using the mscripten compiler. So CPython is, one of the implementations of a Python interpreter. So what we can now do is we can pull the entire Python interpreter into the web browser. So yeah, that's the alternative idea here. Now we have a bit of a different graphic. We could call from the PS Lab application into Pyodide, which would then call into PS Lab Python, which would use PySerial. Now the question is, that's why the question mark is here, how do we call into WebSerial from there? So probably there is also some glue code necessary here. And where I'm drawing the line here, this green dashed line is exactly between what is running from the JavaScript side or from the native website that we can already use. And this here is now everything that is Python, which would sort of run in WebAssembly. Yeah, I don't have a clear answer to the question mark yet, but maybe that's something to look into for the future. And well, just 7 or 8 hours ago, we got a bit of a note on WebUSB. So just in case we would try to use multiple different APIs, that's actually not possible. So we would need to choose between either WebUSB or WebSerial. And it's probably nicer for us to use WebSerial directly. Okay, now let's come to a bit of a conclusion. So first of all, we can port PS Lab to more of a native web using libsilgrok and using WebAssembly. It can be backed by either WebUSB or Web Serial. And we can also reuse the Python code. So here's a call to action. First of all, the link to the issue again, number 697 on PS Lab Desktop. It would be really cool if you could check out the issue and also dump your notes there or maybe try something out. And the slides what I just presented are also again on my website down here. And with that, thank you very much, and I'm open for questions if you have any.
Thank you, Daniel. Since we are running a bit late, I think we can do one quick question. This one's by Nico Kunzman, and it goes, the PyPox app by the University of Aachen features some example experiments that can be done out of the box with the phone. Does the PS Lab Desktop plan to integrate this more user/teaching focused UI structure instead of or in addition to the sensor-centric view? Like, for example, and get started with experiments button and a list of what you can do with the PS Lab?
Yeah, so we have a bunch of experiments that you can do listed in our documentation. That's on docs.pslab.io. That's actually the main entry point to the project if you are curious about the entirety of it. Yeah, that's what I would recommend to look at.
Okay, thank you. And there's a couple more questions coming up in the shared notes. So if you could answer them in the chat, it will be appreciated.
Yeah, I will. Yeah, thank you very, very much.
Thank you very much, Daniel. Next, for our next speaker, we have Masafumi Ota from the Japanese Raspberry Pi user group. Masafumi is now leading the Raspberry Pi community in Japan and volunteering Raspberry Foundation since 2012. She will be giving a talk called Raspberry Pi is 10 years old, and what to do with it, how to share our projects to contribute to the community. So Masafumi is available after the presentation in order to answer questions. Here we go.
Hello, my name is Masafumi Ota. Let's celebrate the decade of Raspberry Pi. This is me. I used to be one of the contributors for Open Source project. After resignation, I have organized the Japanese Raspberry Pi community with Raspberry Pi nerds in 2012. It's been passed over a decade. It's a very long time for me. First of all, please download the wallpaper to your PC or smartphone to celebrate the 10th birthday. I'm happy if you are downloading wallpaper and have fun. This is today's agenda. I will talk Raspberry Pi history though, and you would like to know the status of delivery. First, I will talk about that in detail, and after I will talk the stories. Important production and supply chain update. Before I will talk decade story, I need to talk a supply chain update. You have checked the events log last year. Pi4 1 GB is arrived, and Pi4 2 GB prices up to $45. For business users, Pi3 and CM3 and prioritize and checking the blog, and even recommends the Pi4 1 GB replaced with Pi3B Plus. This is second update. The point is you might use a latest new BCM 2711 based Pi series. If you're hobby users on Education Concerned, you might better purchase a Pi 400. And if you love physical computing, you might better purchase Pi Pico and Pi 2400 based products produced by Arduino and some vendors. And Evan mentioned you to purchase Raspberry Pi from official approved reseller. If you don't know them, please click on the Buy Now button and on Raspberry Pi product pages, find approved reseller in your region. Cyclone is one of the Raspberry Pi approved reseller in Singapore. They are also famous to sell Arduino compatible products. Please don't purchase from Taobao, some of Amazon or shopping website, which is, and you might think, and it is expensive for you, and than you expect. If you they are a reseller, which is not official. Official reseller can be here and I can hear your feedback and support you. I strongly recommend you should purchase from an official reseller directly. If you are business and enterprise users, please ask Raspberry Pi and to business@raspberrypi.com. And if you don't, if you are a startup and individual prototyper for your customers, you can also ask them at business@raspberrypi.com. Looking for Raspberry Pi history working with us. Let's look back my memory over a decade for my Raspberry Pi. Those are mine. Raspberry Pi is one of the streaming system. Still working for my internet radio station, and latest Raspberry Pi works for my business using container BA, Docker, and Kubernetes, and try AI with Raspberry Pi 4. This is my Raspberry Pi Minrack. Works fine on DNS server and etc. This is my first Raspberry Pi purchased from RS Components. I remembered it took over 6 months to get it. It is really easy to use our internet station. First, I have started internet station via MPD in 2009. Next, Bormio. Now using Mixed. It works fine with the Raspberry Pi 4 GB model. Pi 3 is not enough to run. Anyway, it is a really good hobby for me. I have decided on the committee and at open source conference hall in 2012 with Raspberry Pi NAS and friends. And this the first mission on our committee was to get Raspberry Pi 1 to play with. Fortunately, Element 14 helped us. They kindly delivered to us, and thanks and Element 14 to help us. We users group have started experimenting our works and open source conference and in 2013, and welcome to join our members. Now we have over 500 people to join our community. It was first time to welcome Evan in 2013. I was really wondering Evan and Reef loves Japan. Now I am sure they love our country. After that, they have visited Japan several times and have fun. By the way, Evan and Reef have visited many Asian countries. After that, China, Taiwan, and Malaysia. Shota Ishiwatari is the first success with his Raspberry Pi robot named Rapido. He has succeeded in his project Kickstarter in hours. I remember he has started pushing the start button and even helped him immediately and wrote article about Rapido and to official Raspberry Pi website. This combination took Shota to be successful, and Rapido was really famous robot in the world. It makes really easy to learn physical computing. Akira Ouchi, Aki, is the one of the Raspberry Pi dear hobby successor in Japan. He used the eject function in all the CD-ROM and for various functions, open curtains, pushing bells, and 108 times on New Year's Eve. Some of you know named Junokane and more. He continues to works with Raspberry Pi, and he is now an important member for our community. If you have time, please read Aki's latest activity article on Magpie. We have been releasing many more books, including one magazine named the Doujinshi in Japan. Doujinshi are for the comic market and etc. By the way, Doujinshi culture is only in Japan though. It makes Raspberry Pi individual hobby and market bigger and bigger as a result. I will keep watching and helping many more activity Raspberry Pi and under 92-bit environment. It is not only in Japan, but also Asian area too, and send a swag and etc. and help your activities. Please ask me if you need help. Education and with Raspberry Pi. What activity education and market to Raspberry Pi? Coming decade, Raspberry Pi page was divided. Raspberry Pi ORG for programming education for kids. They have programming education training contents translated to many languages and the activity for education and AstroPi and so on. We user groups have been helping and the Raspberry Pi translation project, especially their product. Those are really hard work, and our translation works very hard and works fine for that. We translate official book, keyboards, and Pi400 and documents, and many more. Aki now reading Lego project translated into Japanese. It is really hard work to do and its evaluation. Thanks Aki to do the hard work, and Satoka instructs the guru helping him. We user group have been helping programming contest kids and students. We are now helping Japanese 2 contest. It is the Nikkei Shimbun contest and called Minna Raspberry project and PCN and kids programming community and is now holding the PCM kids programming contest. Of course, and we will have the programming contest and for kids in your region. Please feel free to ask me. I will be your help. And to send some flag and prize for our and something. Enterprise business with Raspberry Pi. Now the Raspberry Pi focus on the business to use Raspberry Pi on business. please check the Liv Upton blog and why it is divided. Now Raspberry Pi and .com focus on the hobby and the individual and the business and the commercial users, and the content is mainly the product and services and some hardware related contents. It is not including education things. Education things is divided to Raspberry Pi.org. Raspberry Pi is now strong effort to enlarge to Raspberry Pi enterprise business and more and more. They now have many business solutions and increase the consultant for your business. So please check carefully on their website to find a good solution. And please ask on the Raspberry Pi if you have on the raspberrypi.com website if you have any question. I have already talked on the powered by Raspberry Pi and branding program, powered by trademark rule and brand guidelines. And please check my old presentation at COSCAP, COSCON, and FOSSASIA, and etc. I will introduce a product information portal that is useful for business. And please note if need, please note it needs registers your account. And it is very detailed. It has very detailed product information, and that is useful for you. Koichi Nakamura the CEO of Eventyay and succeeded his AI business with Raspberry Pi. I know him very well since studying his company Eventyay. And his solution and ActCast is now used many more companies in production. His original AI mechanism makes recognition faster when analyzing pictures and voices and some letters. And it is, he said, and cheaper Raspberry Pi makes good edge AI solution to the company. Vine and Kikushima is a small winery in Katsunuma, Yamanashi. Raspberry Pi is used for measuring temperature and humidity to control amounts of agricultural chemicals. And Kikushima-san was really IT newbie, not so familiar with any hardware and programming skills. So he has built with such listening to compensate his IT knowledge. QT is the latest project I am helping. Peng Chen and a Taiwanese who live in Japan and owns the lead and Raspberry Pi tablet project and called QT. It needs some improvements though. It works good on Raspberry Pi OS and Ubuntu Linux. The UI is great for the tablet. It's also got powered by Raspberry Pi. I met HISCAP and COSCAP a couple years ago. Since then, I have been helping his project. If you are interested in his project, please visit the Magpie website and to read and detailed stories and the latest his activities and his works for the physical computing. I am not only helping the event in Japan, but also helping the event and the contest in the Asian area. Here is a case I have held in Shanghai Maker Carnival in China via DF robot. I have been helping since last year. I am happy to succeed in the event. Also, DF robot has held on the Pi Days, 3.14 day, in China, and I also help in the event sending a flags. So if you have held the event with Raspberry Pi, please let me know. And if you have a chance to have an event and help me to sending some flags, please also let me know, and I will will you help sending some flags and helping some to hold the event and more. And more. And yeah, so you need so there's latest information about that, many things to bring that. And it is a significant update. Pi is not default account because of security issue. Please check the Simon's blog for more detail. It is no longer a Pi account is a default, and you must create the account before logging, and so the CLI version is also have and CLI to so ask to make account before logging. So please note, Pi account is no longer the default account. It's okay, and you have so Pi name, so you create account, but you know if there's some security issue there, and DDoS attackers attack to the Pi account names and password in the Raspberry. So please be careful to manage the account in your Raspberry Pi. And Raspberry Pi Foundation are many more good contents though, but still lack of the main number of the translators. So why don't you join to contribute as a volunteer to translate their good content, and more, you know, it is a good chance to learn translation into English into your languages, and Raspberry Pi continued created many more contents and hope and kids and programming, but they don't have enough contributor to translation. So if you have a time to help them and help translate it, so please help them and to translate their content. Sorry, it is very much conclusion I will review today. First, please check the supply chain update and status, because still suffer to supply chain issued, so you can't feel difficulty to purchase the Raspberry Pi now. So please check carefully to the event message. Do purchase from approved reseller, not official. Especially, you must be careful to purchase from Amazon and Taobao, and which is you feel expensive. Please consider prices and in Apple reseller with others. I will working with Pi over the decade. So we use a group and celebrated 10 months, sorry, 10 years, and we are working over the decade now. It is also past and decade my community, and so but still running and for the community and and help business. I met and Raspberry Pi nerve groove stars really great, and lately and Aki and Pink and a great person to use Raspberry Pi and make more things with Raspberry Pi. They are very good. And please check the Raspberry Pi org, raspberrypi.com pages for education and business, individual and hobbies. I have support not only Japanese project but also Asian project, Qt Pies and more. I will support if you need help. Also, I will help you contest and more. Please ask. Thanks for attending my session. Thank you very much.
Thank you very much, Ota-san. Could you please open up your webcam if possible and to quickly answer a couple of questions? Wait. Yes. Possible to open up your webcam? Hello. Sorry, I can't hear you. Can you press the headphone? Please press the headphone button at the bottom of the screen so we can hear you. Not yet. Could you try saying something? Now you're muted. Could you please press the mute button?
Sorry.
No problem.
First, Michelle,
Yes.
and so Thailand, Thailand is having a question about the Pi 400. So, and the answer is, and so some is the reseller now out of stock, but is the Pi Pico and Pi 400 in the is the first priority to produce and to hold education. And now Raspberry Pi org, raspberrypi.com has been divided, but it is not differences about the mission. It is Raspberry Pi is first priority for education for kids programming. So it is not different. But there are many of enterprise users, commercial users, and some the prototype use. So now they also focus on the business use.
Okay, wonderful. Thank you. Well, I do look forward to getting my hands on a Pi. They're amazing little machines. I really love them, and I hope my kids will enjoy using them as much as I did. So a question is, Ota-san, you are doing a great job building community in Japan. How can we get in touch with more Japanese people like you and invite them to FOSSASIA?
Yeah, actually, and so I talked to the HP fans about that, so inviting the whole digital community, and so hello, I invited a couple of people to invited and talked at the whole FOSSASIA. And next year I will help more people to invite it. FOSSASIA to be a speaker as FOSSASIA.
Wonderful, thank you.
Right?
Another question. I will shorten it down to this. Sorry, because we don't have much time. But do you think Raspberry Pi OS is better than other OS?
Yes. Now it is it is based on the it is also based on the JVM and so the Raspberry Pi OS included many more the applications for the education, and so on. The desktop is improved, so the whole the use and so hobbies and so daily use. So it works good for the education and more. And they also focus on the business for the Raspberry Pi and the OS Lite, even not Gizio OS. And it is good for it is good to use that.
Okay. And on that slight note, if you are a Raspberry Pi enthusiast, I remember the first time I ever used an ARM CPU was on these computers called Acorn. And it was running RISC OS, which you can run on a Raspberry Pi. So next time you have a Raspberry Pi and you're setting it up, try a RISC OS. It's a trip down like the 1990s of computing.
Yes,
okay.
So there are several OS works on the Raspberry Pi. RISC OS, I know you're working. So unfortunately, it is not. It is happy to the Raspberry and the Windows 10 IoT is now and I haven't heard their activity yet, but the Linux-based OS is supported and supported on the Raspberry Pi and Fedora-based and the RISC OS on the others the OS distribution.
Okay.
For can you leave on the Raspberry Pi? And so the OM ask me a question. Sorry. Yes, and if you try to on the Raspberry Pi and try to build Raspberry Pi Pico, you can purchase on the CPU only and Pi RP 2040 and to build that. For there are many more builders using RP to 2040 microcontroller, so you can build the Raspberry Pi by yourself.
Okay. I'm sorry, Ota-san, we have run out of time. It was a very informative talk. Thank you again. Okay.
Thank you, Ota-san, for being here. Thank you very much. We hope to see more Japanese speaker next year. Thank you.
Yes. Thank you very much. See you. Bye.
And we now hand the moderator over to Hongfuk. How are you, Hongfuk? Where are you these days?
I'm doing fine, Mishari. I'm now in Berlin, and I just got my ticket to go back to Vietnam after 2 years. I'm going back home 2 weeks from now.
Oh, that's wonderful. Incidentally, I was planning to head to Japan for a small vacation in June, but then we realized that there's no visas are not yet available. So I suppose I will have to continue to wait unless someone from Raspberry Pi Japan would like to send a business invitation for me and my family.
That's a good point.
Okay, well, without further ado, over to you, Hongfuk. Thank you very much.
Thank you, Mishari. Yes, and up next, we have another session on empower embedded computing with FACS, RISC-V, and free RTOS. This is going to be presented by Oscar Xiang. I hope I say his name correctly, from the National Zhongkung University of Taiwan. Oscar is currently focusing on operating system development, including bringing hardware support to custom system and studying the internals of an operating system. Hello, Oscar.
Hi.
Hi, sorry about the delay. Let me make you presenter.
Okay.
So, Oscar, I have a question. How do I say your last name?
Shang.
Shang,
Oscar Shang.
okay. Oscar Shang. And like, do they call it VEX, RISC-V or VEX, RISC-V? How do I say it correctly?
I say it VEX RISC-V.
Okay. Okay, cool. So let me look for you and give you make you presenter, right? Okay. Could you check if you can share your screen, Oscar?
I pressed it. Can you see?
Okay, cool. So then I leave it to you.
Okay, so hello everyone. I'm Oscar Shang from National Zhongkung University in Taiwan. In this talk, I'm going to talk about empower embedded computing with VEX RISC-V and FreeRTOS. In fact, this is a course project in my last semester, and so I'm going to go through how to use this combination. So here is the agenda of this talk. So basically, I will go through the motivation of this project and why I choose VEX RISC-V and FreeRTOS as my hardware and software choice of this project. And then we'll talk about briefly explain the how to port FreeRTOS to VEX RISC-V. And the last, I'll talking about some difficulty I encountered during the development. So the first topic is the motivation of this project. It's the fact that we are going to enhance the computational power of our devices. It's like the cell phone you use. We try to add more CPU cores or add more RAM, add more GPU to enhance the execution efficiency or the speed. But the fact is that the system must know that you have add cores or some RAMs or the GPU to fully enhance the computational power that your hardware have. And this comes into the fact that we should fully understand the computer system we have, so we can enhance or fully utilize the system we use. But what if the limitation is due to the hardware we have? For example, I have an Raspberry Pi here, and this Raspberry Pi is for 4 cores and 4 GB RAM, and due to this limitation, it is impossible to do something like to run 8 tasks simultaneously on this hardware. So it is the limitation of this hardware. So to advancedly enhance the computational power, we have no choice but to customize our hardware. And yes, we have to customize our hardware. So that comes to the VEX RISC-V. It is RV32 INC CPU implementation. To this, I comes to integer, and N comes to multiplication, division, and modular instruction, and C comes to a compact instruction. And the whole implementation is written with Spinal HDL, which is hardware description libraries. And with these libraries, we can design our hardware with several components. So we can combine those components and build our own computer systems. And for this project, it also integrates a Verilator, which is a hardware simulation tool. So we can simulate the CPU we designed, and we can use extra tools like OpenOCD and JTAG to connect to our hardware and build the software system on top of this. And it is interesting that since we use Spinal HDL to write this CPU implementation, so it is like we have a more high-level view instead of some Verilog or other hardware description language. And with the Spinal HDL, we can generate more FPGA-friendly code and change the design of our CPU more easily. And let's introduce to the actual hardware design of this project. It is called BRIE-SoC, which is the FOSS-RISC-V implementation. We all know that we cannot run our system only on the CPU. So this SoC is try to provide some basic components like UARTs, timer, and some like SDRAM on chip RAM, and and also they have VGA control components. And the most important thing is that the author give us some basic sample codes for utilize this hardware, so we will not have to search the documents all the day, try to look into the source code of the implementation. We can first look into the example they provide. So let's go to the software part. After we have the hardware, and we should also decide to some operating system, so we can develop some other application on top of the system. So I pick up some two candidates of our operating system. The first is Linux kernel, but unfortunately, Linux kernel require more components, which the FOSS-RISC-V doesn't support, which is A extension. The A denotes atomic instruction, which is used to influence the synchronization tools. And the second reason is the virtual memory. We all know that Linux kernel try to isolate process and threads with the address space, but it could more time on porting into a new hardware with virtual memory mapping. So to focusing on the porting or to make the system run on the hardware we write. So I choose the second one, which is FreeRTOS. FreeRTOS is a real-time operating system maintained by AWS. This system uses physical memory directly, which means that we can use MMIO to directly configure the peripheral configuration. And because this RTOS is like a minimum operating system, so they try to drop some fancy things like ELF loaders and other components to make this operating system thin and simple. So it is relatively easy for new hardware to porting. So after choosing the hardware and the software, let's go into try to combine these two components. So here's some simple to-do list for porting the FreeRTOS onto the pre-SOC. The first part is the bootloader. Since we have our own hardware, so it means that the system may not load its image by itself. So we have to bootloader. We need to have a bootloader to load the FreeRTOS image into the chip, into the RAM of the SoC, which is the responsibility of the bootloader. But in this project, I try not to focusing on the development of bootloader. So we use the JTAG pin of this implementation. This JTAG pin can connect with the OpenOCD, and we can use some general tools like GDB to debug our systems. And the second thing is the address map, which is related to the linker script, and this is it is relatively simple because the example we shown before. So this will not take too much time to revise. And the third part is the peripheral setup for operating system to verify the system is working. At this, we should have some text on my show some text on my screen, so we can know that our system is alive or not dead. So we should set up the UART parts for the baud rates and the pins and so on. And another way is to use the GPIO pin to make some LED to blink, and that is another way strategy to verify it. And for the fourth part, it is interesting config in FreeRTOS. It is like the dots config in Linux kernel. It can try to enable or disable some features of the FreeRTOS by modifying this header file. And I have captured some contents in this header file. You can see that we try to enable the asserts with this code from 72 to 74, and we are trying to use some timers, which is enabled by the code in 81. And with this config file, we can try to enable and disable the code without actually looking into the source code. So that's talking about some difficulty during the development. For the first part, which is the exceptions. Exception is like something you're trying to mess up the operating system. So the hardware is trying to protect the operating system from doing wrong thing. So like some classical exception is like page faults, and other exception may be illegal instructions. So in this case, the FreeRTOS, because FreeRTOS relies on the instruction echo, which is environment code, to trigger the context switch. But the FreeSOC will not build with the support of echo instruction by default. So every time when the FreeRTOS trying to use echo to do task switching, and the system will scream like, no, the instruction is not in my instruction list. So the system will do not know how to perform the task with these instructions. So the solution for this problem is to go back to the VESRIS5 source file and turn on the echo generation during the CPU generation. And this is also the benefit of using the spinal HDL. So with this high-level view of the CPU, instead of the very low codes, we can solve this problem like simple and easily. And the second problem is the lack of machine timer. The machine timer is like the main timer in the RISC-V spec. It is defined in the specification that machine timer is to trigger the system ticks, and without the system tick, the system will not know the time is what time is and something like that. So but the problem is that the spec says the machine timer must be implemented as a peripheral. And let's recall the block diagram we showed before. There is no such machine timer on the block diagram. So the FreeSOC would cannot use the instruction provided by machine timer and cannot generate the system tick with the machine timer. But we have some basic timer. We can see the timer is here, and we don't have the machine timer. So my strategy is to make use of this timer in the peripheral block. And the next problem is the tick frequency. As we know, the CPU has the frequency, and this frequency can be used to decide the tick frequency of the operating system. But in our simulation, it is unlikely to decide the frequency because we are running the simulator, so the frequency of the simulator is something like unstable. So during this problem, we cannot set up the proper CPU frequency in the FreeRTOS configurations. And for the project right now, I just try to predefine some values to make the tick work, but it is not that precise. So feel free to try this FastRISC-V pre-SoC and FreeRTOS on your own Linux computer. I use the FreeRTOS base in the last December, and the code I write can be found on GitHub with this link. And the instruction will be to copy this directory and specific extension into the FreeRTOS directory. So you can use GNU-make to build the executable, and then you can start up the simulation and connect with your GDB, so you can test this FreeRTOS on your own computer. Okay, so this is the demonstration of this project. We can see I try to connect the simulator on the left and the GDB on the right, and we pass the operating system image into the simulator and use the GDB config GDB command continue to run the code. And we can see the transmitter and the receiver is doing task switching. Although this demonstration is only includes message passing and some basic multitasking technology or skills, but I think it is the first step and important step to fully customize the computer system we have. And that is some reference I found in during the development. So I think it is the end of this talk. Thank you.
Thank you very much, Oscar. Please send us the slides later so we can upload it on the website and the audience can download the slide from there.
Oh, okay.
Okay, thank you. Yeah, so there's some comment on the chat. Thank you very much. So we thank you. See you next time. Okay, so hi everyone.
Hi. Okay.
So you are here.
Yes. So I'm here to take over the lightning talks, and I just saw the session of Oscar. Very interesting with the demo. Excellent done, Oscar. Thank you very much. And yeah, really like important topic. Risk 5 is going forward. Free RTOS, real time. That's a big topic already for years. We need it everywhere. So I'm looking forward to see what Oscar is doing in the future, Folk. Let's see.
Yeah, perhaps so I just want to say that we should say hello to our viewers from China. So I know that this year we stream on 3 different platforms in China with the help of our partner Kai Yuanshi. We have a few hundred people watching every day from the Chinese network. And yes, so I would like to take a moment to say hello to them. 大家好. 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 Greetings from FOSSASIA. Thank you to our team member Leslie Wong, and with the support of Kai Yuanshi team, making the stream happen. And
do you know that by chance I have a greeting from China from the head of Kai Yuanshi, Emily Chen, who was also visiting us at FOSSASIA before in Singapore, and also at the FOSSASIA Summit that we held previously in Vietnam. So let's have Emily share some words, if that's okay for you.
Yes, of course, I would love to hear Emily.
Okay, I'll share that here now.
Hello, FOSSASIA friends. I think you must have lots of fun during this summit. Kai Yuanshi is a long-time friend of FOSSASIA. FOSSASIA is a good platform and a window for China open source community. Through the FOSSASIA, this platform, we have seen lots of latest projects, the cutting edge technology, and the most influential speaker on FOSSASIA platform. I have passion about the FOSSASIA. I have attended the first ever FOSSASIA in Vietnam, and I have been attend the Singapore FOSSASIA in 2015. So this year, I think me and everyone of China open source community people, we can attend the FOSSASIA online very easily. So this year, we have seen lots of China speakers, projects, and our China annual report has been on the FOSSASIA stage. And so here, I sincerely would like to invite people from the FOSSASIA community to join the China Open Source Conference this autumn in 2022. We are not only going out, we also want to invite our friends from the FOSSASIA to go inside of China open source community. Okay, and see you this year in COSCON.
Yeah, so that was nice. That was Emily Chen from the Chinese open source community, head of Kai Yuanshi. And definitely we'll take it up. Well, we don't know how things are developing at the moment. It seems a bit challenging. Some places are closed down. Yeah, I mean, we stay connected. And as Emily said, we have speakers everywhere and we collaborate. Let's make things happen. So Emily, all the best to you guys in China. Hope to catch up soon again. Yeah, and before we come to the closing of FOSSASIA, we still have like the kind of fireworks of more short sessions to show a bit more of the diversity of this community, what topics are out there and what's going on in our last lightning talk track. And I would like to share more lightning talks now with you guys. Let's see what's going on. We have different topics: TinyML, UNO platform, Alternator, Crew resource management, Anarch, standard for public code, build invincible applications, data center, building and scaling robust zero-code IoT, Pi, and more. And afterwards, stay tuned for some exciting numbers here about the FOSSASIA Summit. And yeah, let's have a look what's going on here with the lightning talks, what people like to share. Enjoy.
Hi everyone, welcome. I'm Archana.
Hi, and I'm Soham, and we're here to talk about our open source project Scale Down, which is helping to democratize TinyML education.
TinyML or edge computing is a machine learning paradigm where we optimize neural networks so that they can run on microcontrollers and other resource-constrained devices. TinyML has become more important with the popularity of the Internet of the Things and deep learning. Deploying neural network on such devices is difficult due to how large they are in terms of memory footprint and the number of operations needed to execute them. So, we need to optimize and scale down neural networks to deploy them. TinyML combines techniques from software development, machine learning, and electronics engineering to run ML models on embedded devices. This means that someone who works in this field needs to have a wide breadth and depth of knowledge in each of these fields. Another problem is that there aren't many resources focused solely on teaching the relevant TinyML concepts, and it can be easy to get lost or stuck when learning this with the typical learning resources. While TinyML hardware may seem cheap, they are still expensive and inaccessible to a large group of people. We believe that this is one of the most significant factors stopping more people from learning TinyML and is one of the primary reasons we created Scale Down. Finally, tools for building TinyML applications are not helpful for beginners to get into the field. The tools landscape is fragmented with different frameworks supporting different algorithms and only models trained with their framework. This makes it a nightmare for beginners who don't know which tools, frameworks, and hardware are compatible with each other. All of these problems motivated us to find a way to provide the community with easy ways to learn TinyML and become TinyML engineers. One of the main goals of our project is to provide community with free and open source resources they can learn from. These will include not only written materials like blogs, books, and articles, but also video tutorials and study groups to learn together. We want these resources to be a healthy mix of academia and industry, so we will also do paper reviews and create tutorials for projects. To help reduce the financial burden on beginners, we want to build a hardware library. The library will be free to use, so users can borrow hardware to learn, practice, and develop and test their projects. Finally, we want to create a framework that is a wrapper over common TinyML tools. This will make it easy for beginners by providing them with a standard API to do similar tasks regardless of frameworks they know or use. We hope to make scale down hardware and software agnostic by adding support for new algorithms and the latest hardware and software tools. For instance, at the moment we support conversions of model from 3 different frameworks and 3 different optimization techniques too. All this will help people build a portfolio of projects with multiple hardwares that they can leverage to get career or internship opportunities.
Now, we'll see an example of using Scale Down to train and deploy a model. First, we'll import the packages we need. This includes the APIs for knowledge distillation and weight quantization. We can load models from either a model file or from code. Next, we can also load the training data and then specify the specifications we want to use to train our model. We can pass these to the API for knowledge distillation that's given by Scale Down. Training a model is just one line, which is kd.trainStep. After the model gets trained, we can benchmark the student model to see its performance. We can also quantize it to float 16 and then create a deployment package that we can deploy to our target device, which in this case is a Raspberry Pi. Now, let's see the result when we run it on our host device. First, we load the model and the training data. Then, we train the model with knowledge distillation. After the model gets trained, we can get a benchmark report which gives us the flops for each layer as well as the breakdown for each layer type. Next, we can quantize our model and then deploy it.
So you can get involved in various ways. You can check out our page and check out the library. We have the list of hardware and specs available. Through the list of hardware and specs, you can go through the hardwares that are present. We have both microprocessors and microcontrollers present. You can also move around the list to see the types of microprocessor and microcontrollers present and see the ones you like. And then you can check on how to request for hardware. We have a very quick infographic here which explains the process, and to actually request, click on this form. You can also donate hardware. There is one more way in which you can get involved. So for donating hardware, you just have to go to this part of the website and click on reach out. And apart from that, you can also be a part of our team. To be a part of our team, you can move under the collaborate with us section and click on join us, and then you can check out the team we have currently. So we already have a few members, and we also have the join us button right out there. We hope we have gotten you interested in our framework. Please do check out our work by visiting the link in the QR code. We would love to collaborate with you to help improve our framework, build educational materials, and work on research projects. You can reach out to us via Twitter or join our Slack. We hope to hear from you soon.
Hello everybody, my name is Martin Zygmunt. I would like to tell you something about UNO platform in this short talk. If you built some cross-platform applications before, you might know that building them is very hard because you have to target multiple different platforms, each having different native language and different UI framework. UNO platform is an open source solution that lets you simplify this by building your application as a single code-based application and then deploying it on Windows, Android, iOS, macOS, Linux, and even WebAssembly and the web. So this is a free and open source solution, so you can find it on GitHub and contribute and send any feedback. And I will now show you how it looks in action. Here is a very simple UNO platform application which is written using XAML and C#, so both languages which are very commonly used by .NET developers. And this application includes a very simple UI and very simple code base in C#. And now the application can be run on all the platforms, including the Windows platform. So this is a Windows application. Here is the same application running on Android with the same behavior. Same application running on Linux. This is running in the Windows subsystem for Linux. And finally, the same application running in the browser. And as you can see, this is running using WebAssembly. So if I do any changes, there are no server requests. This is all running on the client. And it's basically C# and .NET running in the browser. The very cool thing about UNO platform is that it gives you a lot of UI controls that you can use out of the box. So there are things like buttons, checkboxes, combo boxes, and so on. And all these controls are available in multiple different themes. So you can pick the Windows theming. You can pick material design, which looks more like an Android application. And you can also pick Cupertino design, which makes your application look like iOS application. And if you don't like any of these, you can also style and theme your application exactly as you need, because you have control of every pixel of your application. In addition, all UNO platform applications respond to theming of the OS, and you can even switch the theme of your application manually, so you can see how the same application looks in dark theme without writing any specific code. But UNO Platform does not offer only these APIs for UI. You can also build your application using non-UI APIs, which are fully cross-platform as well. So you can check for connectivity. For example, here is a network information API. So if I check for connectivity, I can see I'm connected. And if I switch in the browser to offline, you can see it switched automatically to offline indication, so I now know that I'm not connected anymore. And this is a fully cross-platform API, so you don't have to learn how each platform handles network. You just write single code base, and you don't care how UNO Platform handles it. The cool thing about UNO Platform is also that you can try it out in the browser without installing anything. So you can go to this website, playground.platform.uno, and you can try it out yourself by writing XAML code in the browser, and it will automatically render on the right side. You can also switch between various nice snippets, and this allows you to very easily test out UNO Platform features without committing to anything. And finally, when you're ready to install it, you can go to Visual Studio, manage extensions, and search for UNO Platform, which will give you the UNO Platform solution templates. And then you can build your UNO Platform solution by creating a new project and choosing multi-platform app in UNO Platform. So this is the end of my short talk. You can try it out yourself. Go to platform.uno for any tutorials and documentation. And if you want to contact me and get more information from me, you can find me on any of these social networks and on my blog. So thank you very much. Have a great day and enjoy the rest of the conference.
Hello everyone. Today I'll talk about Alternator, which is an open source implementation of the DynamoDB API manufactured at ScyllaDB, where I currently work. I'm a software engineer at ScyllaDB and lately also maintainer of our Rust driver. I also worked on the Alternator project. Before I talk about Alternator itself, I'll mention ScyllaDB, the database on top of which Alternator is built. ScyllaDB is an open source NoSQL database focused on maximizing the performance and fully utilizing the underlying hardware. Its original goal was to provide full compatibility with Cassandra API, which is already long done. An important difference between ScyllaDB and Cassandra is that we're built on top of a high-performance async C++ framework, C*, also implemented by our company. The framework is also open-sourced under a permissive license, and you're welcome to browse it and use it. A ScyllaDB cluster, similarly to Cassandra, acts as a kind of distributed hash table. Each server in the cluster is responsible for part of the data, which is also replicated, and so on. Now, Alternator, what is it? It is ScyllaDB, but with another API that it supports, and it happens to be compatible with DynamoDB. It is not a separate sidecar proxy program that you launch and it translates queries. No, you just run ScyllaDB and configure it properly so that it listens on a specific port which understands DynamoDB API. That's it. Alternator is only one of the frontends that ScyllaDB supports, which means that the whole storage layer remains the same. In particular, if you already know Scylla from DevOps perspective, you'll be familiar with all the tools. Monitoring based on Grafana and Prometheus works. You can use the same mechanisms for backups, repairs, and so on. So how does Alternator differ from DynamoDB? Ideally, we want it to be fully compatible. However, there are still some things we don't support. On the other hand, we also provide a couple of extra capabilities. First of all, ScyllaDB is just an application which you can download or even compile for yourself and run it even locally. It also means that we usually expect a dedicated installation, not a multi-tenant giant, which DynamoDB is. Thus, we also don't implement all of the capabilities like throughput limits yet or charging per byte, because the server can simply run standalone, not only as a service. We keep an up-to-date compatibility list online. You're hereby encouraged to take a look. I'll go briefly through the list. We do support authentication, but it's currently tied to SQL authentication, the native one, so it's not really user-friendly, but it works. There's no access control list support yet. Our global secondary indexes work just fine. But due to ScyllaDB's underlying implementation of materialized views and how we store data internally, we cannot make them as dynamic as in DynamoDB. In particular, you need to create an index upfront when creating the table. It cannot be added to a table later. All of our tables are global in DynamoDB terms. One cannot make a table local to a data center. TTL, time to live, is still work in progress, but it's already available in experimental mode. And we don't yet fully implement full-fledged multi-item transactions. We have conditional updates based on compare and swap. So conditions like if exists or if some value equals to some other value works. We also don't have the same observability routines. Alternator uses the same metrics system as ScyllaDB, which is based on Grafana. We also expose a way of reading extra metrics, for instance, how many reads were performed lately via an extension of the DynamoDB API. You read from a synthetic table with a special name, and it returns rows which correspond to metrics kept internally by ScyllaDB. All these metrics, as you can see, are extremely useful when looking for bottlenecks and overload issues in your database cluster. That sums up my lightning talk. Alternator is an open source DynamoDB compatible API that runs on top of ScyllaDB, a super high performance database. You can deploy it locally or on Google Cloud, Azure, or any other vendor, which is quite cool. Various tools from ScyllaDB ecosystem like tracing and monitoring, but also backups and many more things can be used along with Alternator that simply work. And you're welcome to play with it and see if it's worth switching from the original DynamoDB. Thanks everyone, that's it. Please reach out to me if you have any questions or would like to contribute to the project since it's open source. Thanks.
Hello, and thank you for coming to my lightning talk. One of the interesting things that I learned at Adjust was that the way in which we work together can make a big difference in terms of the stress that we face when something goes dramatically wrong. Now, many of us have heard of Google's SRE framework, and I'd like to talk about something that I think is an absolutely great complement to that framework, which is crew resource management. Now, crew resource management's a really interesting field. I'm not going to go through too much of what's on the slide, except I want to highlight something that's not on it, which is that crew resource management is as much a skill and technique-based training as it is an organizational commitment towards trying to make sure that we communicate and work together in an appropriate way. And it's also something which is built very much on cognitive psychology in order to try to understand how we make mistakes, in order to make sure that we set things up so that where we have decision points in our runbooks and things like this, we can set things up in a way that makes human error less likely. So this is very much a set of tools and ideas and a framework for understanding human error. It's not very much of a set of formal processes, although you can build some formal processes around them. Crew resource management is a fairly vast subject. It's now been implemented in a large number of fields, including medicine and nuclear power plant. Nuclear power plant management. It consists of a whole bunch of subfields, but I want to stress one of them in particular, and that is workload management. When we talk about workload management, most of us think about what's going on from 1 month to the next, how much we have to do within the next month. This is sort of an extension of that, but it's tied down to, say, the next second or next minute. And the idea is that if we have to keep more things in our brain and we have to pay attention to more things at the moment when something goes wrong, then we are more likely to make mistakes. So focusing on workload management in terms of how we write our runbooks to try to reduce the workload when something goes wrong is really important. Automation obviously is part of that, but so is making sure that we don't have to scroll in order to figure out what the next step is. So that's an important one. Also, there's a lot that goes into decision making and problem solving. That's another really big field, but I don't have time to go into that right now. As I mentioned before, SRE and CRM frameworks are quite complementary. SRE as a framework focuses very much on the engineering that's required to have reliable services that are still under development and may in fact, have outages for human factors and environmental factors. While CRM is very much about those human factors and how do we come together when something's right or something's wrong, and really operate with each other to the best of our ability in terms of technical and intellectually demanding work. So there's certainly overlap. I listed 3 items here: risk management, postmortems, and safety risk culture. These are things where the SRE contributions to the field can give you an outline on how to get started, but the CRM frameworks can give you a richer framework in terms of what to focus on to better optimize your safety risk culture, create better postmortems, and ultimately create the sorts of services that your customers value. Thanks.
Hello everyone, this is Shraddha. I'm going to talk about a NAX project, its working, and a little demo at the end. The crucial problem that the NAX deals with is the trust and the isolation in the remote cloud environments. In the cloud environments, hosts and owners of different layers can pick into the sensitive data without you knowing. For this issue, there are different trusted execution environments, or TEs. A TE is basically a secure area in the host to run the sensitive workloads. Only the CPU has access to this TE. So if any other layer tries to access it, then they are denied the access. All this is good. So why do we need a NAX? TEs are awesome, but they have few limitations. There are different platforms for TEs, and for each platform, we have to develop the application differently. For writing those applications, you need to use different SDKs, and they restrict the language use. The third important part is the attestation. There are different attestation models used for different platforms. Lastly, there are different cloud vendors currently in the market. Handling these third-party products and their vulnerabilities is very risky. So NAX is focused on getting rid of all these limitations that are posed by TEs. Let's take a quick overview of the NAX. It uses TEs for confidential workloads. It makes the development and the deployment easy using WASM. It has strong security principles for reducing the trust relationships. It's cloud native, and it has been made open source. So it basically, the NAX removes all limitations by creating the platform agnostic, easy to develop and secure system to deploy the sensitive workloads to the remote host. Let's understand how the NAX is reducing the limitations in more detailed manner. This is a normal structure of the systems on the cloud. NAX focuses on reducing the trust relationships. So we just need to trust the CPU and the firmware and wipe out the need to trust any of the other layers above it. The most important thing here is the NAX is a deployment framework. It can let you choose whatever language you want to develop an application in. You just have to compile it to the WebAssembly and need to choose the host, and then you are ready to deploy it to the NAX skip. Let's go to the demo part now. The demo is based on the scenario where we want to carry out a confidential transaction in a trusted execution environment using zero knowledge proof and with the help of NAX. Let's first understand what ZKP is. ZKP is used when you want to carry out a confidential transaction, or we want to do a statement or a secret without sharing any extra details about it to the other party. It's highly used in the cryptographic and authentication system. Let's take an example here. Here are Bob and Alice. They will help us understand ZKP. So Bob and Alice decide to go to dungeon raid individually. After the raid, they want to see if the number of coins is same or not without revealing any other information about their gains. Considering they can have coins between 10 to 25 range, Bob pulls 4 lockable boxes with the labels. Bob keeps the only one key to the box whose label number is same as his number of coins. That is box with label 10 and throws other keys away. Alice has different paper markers. Green marker for the box which has same label number as her number of coins and red marker for all the others. Since Alice has 25 coins, she puts the green sticker inside it and puts the red sticker for all the others. At the end of this procedure, Bob opens the box number 10 with his key and he finds that he has red marker, meaning that his number of coins is not equal to hers. But he doesn't know how many coins she has and no other information is revealed. This is what the ZKP is. We are done with the theory part now. Let's go ahead with the implementation. We are implementing a non-interactive type of ZKP, that is bulletproof. Simply speaking, the prover will create the proof, send it over to the verifier, and then the verifier will validate that proof and say if the proof is valid or not. Let's check out the demo now. In the code, I have added a range proof, which will use a bit vector n and will check if the secret is in the range from 0 to 2 raised to power n. And the commitments will be there, which will create the agreements and are passed to the verifier to carry out the verification process. Here we are taking the two inputs, secret and the bit vector. First of all, we will be compiling it the WebAssembly and then run it in the anarch step. In the first example, I will be taking the secret as 7 and the bit vector as 8. Since 7 is in the 0 to 256 range, proof is verified. On the other hand, I will be taking the secret as 286 and the bit vector is 8. In this case, proof will not be verified since it is not in the range. This is how the applications can be easily deployed on top of Anarch and will provide an additional layer of security for our sensitive code and data, as well as making this development process much easier. So we have got to know how ZKPs work and how to run them on top of Anarch. Thank you, everyone.
Hello. Hello there. So my name is Eric Herman, and I'm a code-based steward at the Foundation for Public Code. I'm a developer with a long history and a long-time FOSS contributor.
I'm Jan Einali. I'm also code-based steward at the Foundation for Public Code, and I've been in various ways working with open content for well over a decade.
One of the questions I get asked a lot is, what is public code? And so we see public code as free and open source software developed for and by public organizations to achieve a public purpose or a public policy, and that's what makes it public code.
And what we see is that more and more policy are using software in parts or in whole, so it essentially becomes public infrastructure.
And you have almost certainly experienced that anytime you're interacting with government, that it's less and less often that you're going to an office and to a desk, and more often that you are going to a web portal or similar. And so at all levels of government, whether it's municipal or national, we're seeing this digital transformation of the public sector. And what's different about the websites that are run by public organizations is that they have much more stringent demands when it comes to transparency, reliability, accountability, but even in the development process, predictability about when that software is going to go live, and definitely things around sustainability, and we're even seeing sovereignty as being one of the more important drivers.
And all these demands can be quite daunting if you're a small public organization or administration. If you're a municipality, and that's why we're seeing them ending up working together, because they have similar needs. The next municipality is not likely to have very different needs from what I do.
To enable this collaboration, we have the standard for public code, and the standard itself is a group of 15 criteria, each one enumerating a set of requirements that allows the collaborators and the reusers of the software to have the confidence that the software that they're working together on is going to meet those strict, stringent requirements that they have.
And the standard is in English, and it has community-provided translations. The first one out was Spanish, and we have a Danish translation being reviewed right now, and we're hoping to see a lot more of these over time.
When you look through these individual requirements under each of the criteria, you're not going to find anything there that is going to be really novel. If you're a software developer, almost every one of these is a practice that you are probably already doing, or you wish you were doing if only you had the time and management support to do it. So only things that I think you're likely to find that might be different is that if you don't have a public sector background, you probably haven't really thought much about how policy interacts, but all of the ones related to the software development itself are going to be extremely familiar.
And that's sort of what sets the standard for public code apart from regular engineering guidelines. It's giving the different roles, all the layers in your project, an assignment of what they need to do to make this work.
When you have that understanding that we're collaborating on the software, that it's different than buying off-the-shelf software, obviously that means that there's going to be changes in procurement, because no longer are we buying a license for 3 years. Instead, we are investing in what are the next features that we need, and then as we learn from that, in very typical agile software development way, investing in what are the next set of features that we're going to need or need to deliver quickly. And these things do involve a change in risk, and part of having that whole support from top to bottom is understanding how that does change the risk.
And what we're seeing is that, of course, you will invest in the parts that you need the most, what's your highest priority. And you will see that you will benefit from what other people contribute back to the code base. So investing in the collaboration does not cost, it pays.
Currently, the standard is at draft version 0.2.3. We have it hosted on a repository up on GitHub, and we absolutely welcome contributions.
Thank you.
Hello and welcome to this lightning talk for FOSSASIA 2022. I am Dominic Torno. I am a principal engineer at Temporal. How can you develop always available systems while also enjoying a delightful developer experience? In this talk, we will learn about the important role of core abstractions, a key ingredient in answering this question. Core abstractions are the fundamental building blocks of your system. A core abstraction mitigates a set of challenges on a platform level, while it entirely eliminates that set of challenges on an application level. Let's look at 2 examples. First, we will look at a well-established core abstraction in the context of database systems. And next, we will look at a recent core abstraction in the context of distributed systems. First up, database systems. The database community faces many significant challenges. Here, I will focus on 2, the presence of failure and the presence of load. If a database system experiences failure, some operations may have taken effect already, while other operations may not have taken effect yet, an anomaly known as partial application. If a database experiences load, some operations may interfere with each other, an anomaly known as a race condition. Obviously, these challenges threaten your system's consistency, its correctness. However, for the past 45 years, the database community has enjoyed an unparalleled developer experience. These challenges do not seem to be on anybody's mind. Why? Because the database community introduced a core abstraction: database transactions. A database transaction is a sequence of read and write commands that terminate with exactly one abort or exactly one commit. In case a transaction terminates with an abort, the database system guarantees that the resulting state of the database is equivalent to a state where the transaction did not happen at all. In case the transaction terminates with a commit, the database system guarantees that the resulting state of the database is equivalent to the state where the transaction happened exactly once and in isolation. In summary, a database transaction guarantees that the resulting state of the database is equivalent to the state where the transaction didn't happen at all, or where the transaction happened exactly once. So a database transaction mitigates failure and load on a platform level, entirely eliminating failure and load on an application level. As a database developer, I develop my application as if failure and load do not even exist. And as a database developer, because transactions are a well-established abstraction, I take this developer experience for granted. But not every community is so fortunate. Case in point. Next up, distributed systems. The distributed systems community too faces many challenges. And once again, I will focus on two. The presence of failure and the presence of time limits. As previously, if a distributed system experiences failure, some operations may have taken effect already, while other operations may not have taken effect yet. Again, the anomaly of partial application. If a distributed system approaches a time limit, operations may be terminated, an anomaly known as a timeout, which in turn may result in partial application. Again, these challenges threaten your system's consistency, its correctness. Unfortunately though, the distributed systems community does not enjoy a developer experience similar to the database community. These challenges are on everybody's mind all the time. Why? Because we have not established a core abstraction. We are unable to mitigate failure, unable to mitigate time limits on a platform level. We mitigate on an application level. Our application code is painfully aware of failure, painfully aware of time limits. We break up our computation into chunks, wrap those chunks into retries in order to mitigate failure, and then stitch those retrying chunks back together via databases, queues, and cron jobs in order to mitigate time limits. Let's face it, our application code is just a hot mess. However, recently we are witnessing the advent of a new core abstraction. The distributed systems community is introducing the concept of a workflow. A workflow is to distributed systems what a transaction is to databases. A workflow is a sequence of commands. A workflow guarantees that the resulting state of a distributed system after executing a workflow is equivalent to the workflow executing exactly once and to completion. Now once again, workflows mitigate failure and time limits on a platform level, entirely eliminating failure and time limits on an application level. With the core abstraction of a workflow, it is both trivial and delightful to build correct systems. One example of a popular workflow system is Temporal. Temporal is an open source workflow as code workflow system. Workflow as code refers to the fact that you can author your workflows in code. For example, in Java, in Golang, in JavaScript, TypeScript, PHP, any language that Temporal has an SDK for. Temporal lifts a regular function into a workflow. In other words, a workflow is a regular function but with additional execution guarantees. Check out this example. This snippet illustrates a workflow that loops forever until it hits an exit condition, sleeping 1 month in between iterations, as if failure and time limits do not even exist. Curious? Learn more about workflows and workflow systems at Temporal.io. Thank you very much for watching and enjoy the rest of the conference.
Hello everybody, welcome to my lightning talk session, Data Center Infrastructure Management used as a single source of truth for telco operation. My name is Thắng Trần Văn and my mentor is Vinh Nguyễn Trọng from Viettel Network, and Viettel is the biggest telco in Vietnam. So the first thing I will explain DCIM. DCIM is Data Center Infrastructure Management, a tool or a software to manage all resources in data center. In my company, we extend DCIM to manage more resources. We manage not only the physical device, but also the network device, logical device, and other virtual device. For example, it could be a virtual machine, load balancer, firewall, and some service. Thus, every big company will have a database or a quality cluster. So we design DCIM to have many goals. So the first thing we make DCIM to digital infrastructure. And it's a part of my company vision, digital transformation. And we build DCIM to be a swap to save information configuration for many devices. And we make DCIM to make IT facility, DevOps, Dev Manager, CTO, and many roles become closer. And the main purpose we build DCIM is will become a source of truth for provide information for other systems. You can see image here, DCIM to provide information to monitoring, device inventory, network automation, and many other stuff. So how we do that? And we use and customize networks. And network is an infrastructure resource modeling (IRM) tool designed to empower network automation used by thousands of organizations around the world. And network is open source and currently very active and has many contributors over the world. And we custom network to build DCIM to manage 1,000 devices and virtual machines. And we manage not only the physical device, but also the logical device and virtual device. So to do that, we use a lot of available features on network. Besides that, we modify and add more features. For example, when we manage the firewall, we must standardize the model to fit all the firewall. Because the firewall has many providers, many types and versions. And besides that, we must link the firewall model to other available model on network like IP address, device, and tenant. The second thing, we build the discovery service. This service is our network, and it will get information, get configuration, get secret from network via API. Then it will run any script like Python code, Ansible task, some command line via SSH, Telnet, and some other protocol to get information. Then we passing and modeling and comparing the data, and finally we push the data back to network. So network is always has the current state data, and it will make network a source of truth to other systems. So it's a quick look about our DCMI solution. If you have any question, please contact me via GitHub, Facebook, or email. This is the end of my lightning talk session. Thank you for watching. Have a good day.
Hello, my name is Paul Brebner. I'm the Technology Evangelist at Instacluster, and this talk is Building Zero-Code Streaming Data Pipelines Using Open Source Technologies. So it's a lightning talk. It's an update from the talk I gave last year, and it involves two forks. The technologies include Kafka Connect, which is common, Elasticsearch, and Kibana, which I talked about last year, and the second pipeline, PostgreSQL and Superset. So previously I talked about building a Kafka Connect pipeline, This is a photo I took in Berlin at ApacheCon a few years ago. I wondered at the time whether perhaps it transferred water, beer. In fact, what I'm going to talk about is a water data source. The source data is the NOAA tidal data, which comes from a REST API and gives you access to hundreds of tidal data sensors around the world. The first pipeline consists of the NOAA REST API with data fed into the REST source connector, then to Kafka, and then the Elasticsearch sync connector, and finally Elasticsearch and Kibana. There's an overview of the architecture. This is an example of one of the visualizations in Kibana, just showing the data as sort of like a graph. You can see things like the lunar day and the tidal range. But what can go wrong? Well, I left the system running for a few days and discovered that some of the connectors were failing. And it turned out that sometimes there were JSON error messages, and sometimes there were even non-JSON errors being fed into the system as well. And the connectors did not cope very well. So what I needed was improved error handling, and I discovered the Apache Camel Kafka Connectors project, which has a very large collection of open source Kafka connectors with robust error handling. So what's new? This is the second path. It's basically a different pipeline with new syncs added. The PostgreSQL sync connector, feeding data into PostgreSQL, and then visualization using Apache Superset. Some of the challenges around this pipeline were finding open source PostgreSQL sync connectors that work with schemaless JSON data and which can insert that data into JSONB table columns. And then finally configuring Apache Superset to read the JSONB data and visualize it. Superset has lots of visualization options. Here's just one of many examples using a scatter plot. The size and color show the sea level trends and explain perhaps where you should and shouldn't buy property in the near future. I also investigate scalability, how well do both systems scale. And in the conclusions, which you can see in my blogs with the URL there, you'll see more details about the scalability and cost comparison between these two pipelines, a more detailed evaluation of Kafka Connect, and a comparison of Elasticsearch versus PostgreSQL and Kibana versus Apache Superset. This is part of a 10-part pipeline blog series, and it's got all the details and more. And finally, there's a new service that we're offering at the moment for Cadence for workflows, and a new series that I've started called Spinning Your Workflows and Drones with Cadence, which looks at an example drone delivery service. Well, thank you very much. I hope you enjoyed that lightning talk. Please check us out at the website. We have a free trial for 2 weeks that you can try any of these technologies and more. And I hope you enjoy the rest of the conference. Thank you for listening.
I'm an open source evangelist. In today's talk, I'm going to introduce PyPI, a programmable network proxy for cloud, edge, and IoT. Here's the agenda for today's talk. I'll be briefly explaining what is PyPI and its key characteristics. Then we will take a high-level view of PyPI architecture and design, and in the end, I'll be sharing the links which can be used to learn more. So what is PyPI? PyPI is an open source, lightweight, high-performance, modular, programmable, cloud-native network stream processor. It has been used and can be used in different use cases like proxy solutions, load balancers, edge routers, API gateways, sidecars, and so on and so forth. I have highlighted the keywords which have specific meaning, and I'll be explaining them in the next slide. Compiled PyPI executable has zero external dependency and is around 10 megabytes in size, and it requires a very small memory footprint to run. PyPI is written in C++. It leverages asynchronous networking. Allocated resources are pooled and reused. PyPI is versatile and it has been used or can be used in multiple use cases, which we'll explain in previous slide. PyPI comes with its own built-in custom JavaScript engine called PyPI.js and has no garbage collection overhead, and it implements a subset of ECMA standard. PyPy provides a range of pluggable building blocks, also known as the filters, which can be chained together in any fashion to build a pipeline. I'll be talking about pipelines and filters in the next slides. PyPy is fully open source and all the source code is available on the GitHub repository. Just take a look at the architecture and design. PyPy is stream-oriented, where it takes streams in, processes them, and outputs the streams. PyPy is event-driven in the sense that PyPy streams are made of events instead of bytes. There are 4 types of events in PyPy: the data event, and 3 non-data are known as the marker events over there. A stream coming along from the network is a series of data events, each holding a chunk of bytes received from the receiver communication there. Events are processed by a chain of filters, where you can think of filters like a tiny Unix process that reads from its input, writes to its output, with the output of one filter connected to the input of the next. Chain of filters in PyPy is known as the pipeline, and that's the key concept in pipeline, and PyPy provides 4 different categories of the pipeline. The port pipeline is the one which is used when you are writing a network service which listening on particular port, and if you need a cron job like functionality, the periodic timers there, then you go with the timer pipeline. And if you need to process the signals which are sent to the Unix process, then you work with the signal pipeline. And the sub pipeline is a unique one that can only be called by the joint filter. Port, timer, and signals pipelines are known as the root pipelines, and they cannot be invoked by any joint filter. A PyPy module is a PyPy.js source file containing the PyPy script that configures a set of pipeline layouts. Actually, as you see, that the pipeline layout is actually how you compose or chain the filters together, and each module has its own context. The context is actually where you define the variables which can be used internally and only visible internally through this module. But you can use the export and import functionality to export the variables so the other modules can see that one. Here's a look at a simple hello world examples there. So what we are going to do is actually we are writing a simple PyPy script that is going to listen on port 6080, and it's just going to return hi there to every HTTP request, no matter what verb you use. Here we are actually using 3 different filters there: decode HTTP replace message and encode HTTP response. On the left hand side, actually it shows the visual depiction of the messages or the events which happen inside the PyPy. Don't worry, actually, if you just need to write a simple hello world like script there, so you can do that with only 3 lines of that one. The one in the right side, actually, you can see here the line 4 to 8 on the top one side can be replaced with line 4 to 6. The server HTTP is actually the same as doing the decoding, replacing message, and encoding the HTTP response. PyPy comes with Admin Web UI that actually provides you the IntelliSense syntax highlighting of the PyPy scripts, which you can use to develop the PyPy scripts over there. On the right hand side, actually, you can see the visual depiction of how the pipeline look like. Please visit PyPy website flowmesh.io for more details, or you can subscribe to the Twitter handle PyPy Proxy, or you can join our Slack channel. Thank you so much.
Alrighty. How did you like that? How did you like these lightning talks? Please let me know in the chat. And yeah, we are coming out to the final session of the FOSSASIA Summit 2022. I would like to invite team members here into the session. And yeah, let's have a wrap up. But I have a good feeling. I have a good feeling about it. And how about you, Hanfok?
Yes, we have come to the end. Of course, I also have a very good feeling, excellent feeling. We completed 3 days of the FOSSASIA Summit.
Awesome. So, what about you guys? Marco, Roland, Yasmin, who's here? Who wants to join the final session? I think you guys just join step by step, and we already discuss some points. How was the open source event here? How was the FOSSASIA event? So, hi, Yongbin. Great to see you.
Hello.
Okay, first to jump in. So, as you guys are joining, I think we can already go through a few points here for the closing. And Folk, would you like to share what you're sharing?
Yes, so we have come to the end of the summit. So while we are waiting for the team members to join step by step, I would just like to take the opportunity to thank our sponsors and partners. Of course, we already know the event organized by FOSSASIA and OPM Tech. And let's take a moment to say thank you to our sponsors and partners.
Yeah, so I have a video with some sound here. Let's say thank you to them. So I see from our team members here, only Yongbin has the rhythm, right? Really dancing. I would have bet that Marco has the rhythm, but in the end it was Yongbin. Folk, please go on.
Yes, so some of the team members are not here today, but on the screen you see this is the team behind FOSSASIA. I'm very glad to work with friends and colleagues from everywhere around the world. So we have people from Vietnam, from Australia, from Spain, from the US. Thank you very much for your work. Without you, it wouldn't have been a FOSSASIA Summit. Like today, I'm very glad and I'm super happy to get a chance to work together with all of you. So perhaps each of us can just say hello from one row and say where you are right now.
Greetings from Singapore. Hello.
Hello, Roland.
Hello. Greetings from Shenzhen, China. Yes.
Why don't you call on the next person, Leslie, so that would be more organized.
So, Riley, hi, our friends from Kaiyuan. Will you say something?
Hi, I come from Shanghai, China.
Yes, nice to meet you. Wonderful journey. Okay, next one. Who's going next? Marco, would you like to say something?
No, Marco, we don't hear you. Leslie, you have to call out somebody else then.
Well, okay, maybe Yasmin. Would you like to say something?
Yeah, it's great with FOSSASIA. It was my first experience, and I was really impressed at how the summit brings different communities on a single platform to share innovative ideas. Yeah. So I'm looking forward to being the part of FOSSASIA team again in future.
Where are you based, Yasmin?
Actually, I'm in right now in Berlin, but I'm from Pakistan. So next, I'm gonna nominate Yongbin.
Oh,
Yeah.
hello. I'm Yabin Han from South. And I also hope to see you in person next year.
I think Hung New.
Hello, yes, I'm Hương from Hanoi, Vietnam. This is my first time joining FOSSASIA team, and it is very nice experience to work with you all from different regions, with different background, and I'm so glad that I have this chance to learn more about technology and experience work from for organizing a big event. So I'm looking forward to meet you in person. If you ever come to Hanoi, visit me. Video is the best, and take care.
Okay, good to hear from everyone. Mario, I think now we can continue to share some numbers.
Sessions, 24 lightning talks, 23 project showcases, over 2,000 social media posts, and 400 questions. I think with the questions, it was really cool to see how the audience interacted with the speakers. Okay, Hongfolk, you want to do the next slide? Oh, I think that is up to me, right? So we have here the overview of the Big Blue Button main hall. What we can see is that on the first day, we actually had a huge hike right at the beginning. This was expected. You always have a lot of people attending the opening, learning about the event, learning how things work, and then they will join specific sessions. So it's a bit going down, but like we had most of the time around 40 to 50 participants, where I have to say these were not unique participants because right, like sometimes somebody comes in twice, and yeah, we are still figuring out how to evaluate those numbers. Here is a view of
we had
the
10
first
people who
in detail. Roland, yes, Roland, you have a comment.
We had 10 people who didn't go to bed on Saturday night.
Yes, apparently that's the case.
That was going to go to zero on Friday night, but did not go to zero on Saturday night. Wow.
Yeah. So
great enthusiasm.
They might have left the computer on. They just wanted to like wake up right with the first soundbite, and yeah, that could be the case. But yeah, imagine, right? Somebody just stays there. Pretty cool. So here's a view of the first day. One thing that we realized, there were some glitches with Big Blue Button this year. Even though we took a big server, we had everything set up. We have to analyze that, go back to what happened. We also had an update to a newer Big Blue Button version. Our hope was that the system would be more stable with that update. Unfortunately, it wasn't the case. There were quite some crashes. And yeah, at the beginning, we tried to restart the server here. As you can see, at like 1320 on the first day, there's a big drop when we actually restarted the server. And yeah, there are a few drops that we could identify when the server was restarted. But yeah, we made it happen. People stayed on board. People participated also on the second day, which you see here. So we can analyze now which sessions were really popular. Like there's a hike at some points. And yeah, cool. And the third day, which is not complete because we just captured until like 3 hours ago. And on the third day, we see like people really came in towards the afternoon. Maybe it was Saturday a lot of people wanted to sleep into the day and joined the summit only at a later time. Okay. Yeah, and of course, for people who are really into tech, here is an analysis of the CPU, memory, and network traffic. Yeah, actually, we didn't really use a lot of CPU all the time, but we use quite a bit of RAM. So I wonder if that was an issue here with the RAM usage that resulted in some crashes. You can see, for example, on the the 8th, on the second day, we have kind of a clash down at one point. Have to analyze what happened at that time. And network traffic is always also not always very clear. For example, today we had a huge hike in network traffic. I don't know what that was about, what was the cause. Definitely will be interesting to look in more detail at those numbers. Okay, Hongfok, would you like to continue? Okay, so I'm taking this slide then as well. So we have unique participants here, and the unique participants are, I have to say, from the streams. So they're not yet from calculated here from the big blue button, but these unique participants are from the streams. So, for example, the streams in China, we had streams at Bilibili, WeChat, all from the stream at YouTube here in Germany. Leslie, do you have anything to add about those streams?
Yes, we have a separate WeChat group. There are over 300 people there, and we keep monitoring that group and inform the update of our presentations. So
yeah.
Yes, that will be another source of influence.
Yeah. Yeah, of course, like it's always challenging to have like the exact number, because maybe somebody
I think we have
viewed
some
one
graphics.
stream. Yeah, we have some more graphics. Okay, please go
Some
ahead.
more graphics. You control the slide. Could you?
Yeah, I give the rights to you. You can just go through them.
Yes, I think we have some graphics. So Leslie and Lee, if you want to say anything about this platform from China. So I think this is generated from the Chinese stream. This is from Leslie. This is day one, right?
Yes. This is from day one. Maybe Bradley can Mr. Bradley, can you turn on your mic and say something about this? Oh, hi.
Okay. We not only 300 people group, you know.
I explain. Mr. Lee actually he have forward the live stream to many groups, to about 7 to 8 groups that all about open source, and each one of them over 300 members. So the influence it's quite influenced. Although maybe not everyone entering the stream long towards, but they do get information from FOSSASIA Summit. All right.
Thank you, Leslie. Thank you, Mr. Lee. Excellent work. Yeah, to get us connect with audience in China. Thank you very much for your work. Yes, and this is also, as we know, we stream on our YouTube, and this is some numbers coming from the YouTube channel over the 3 days. So I think today we still need to get the number at the end of the day, because the stream is still going on.
So I wonder if Yongbin could share a bit
Yes.
about those numbers.
But to add some comments, the YouTube analysis doesn't give us the data hourly or per minute, so they just solely keep the data daily data. So that was the all data I could get. And as Hongpu mentioned, the day 3 data is not fully available yet. After the event, maybe you can get some more data for the day 3.
Hey Yungbin, why don't you also share one learning that we get from streaming to YouTube about the limit of the number of hours we could stream? Maybe it's also useful for other communities.
Yes, right. We actually on the day 2 and day 3 we have more than 12 hours of the event hours. But the YouTube Live only supports having the live streaming up to 12 hours. So if we stream more than 12 hours, like if we go like 13 hours, 14 hours, and if we finish the streaming, the recordings are not available at all. So we lose the whole recording. So that makes us to split the streaming to the 2 parts. Like if you on the YouTube, you should able to see that there's a part 1 and part 2. That is because the limitation of the what YouTube provides.
Yes, thank you. So I think this is something something new that we learned this year, because previous year, I think every day we did not have more than 12 hours. So that is really good information. Thank you, Yungbin. Okay, so where do the FOSSASIA Summit participants come from? Yes, this is the map. Yeah, people come from all the continents. So we even have someone from Africa, from the US, Australia, and you see right in the center, the green color. This is the country that got the highest number of participants, which is India. Yeah, this is not a surprise to us that we have a strong community in India. A lot of FOSSASIA contributors are from there. Mario, do you have anything to add about the participants?
Yeah. So what we see, I mean, it's really amazing to see participants from all over the world, but we also see actually that less countries in Africa are covered. We also see that Eastern Europe is not participating in the event, like also from Ukraine. Of course, like it's because of the situation there. Apparently, people have something else in mind. They have like tough problems in regards to war. With Africa, I'm not sure about like each single case. I think there are a number of reasons, there are drafts, there are also local wars. So it's pretty sad how this is affecting the global open source community, who's not able to get together everywhere in the world. Even though we have quite a large area of the world covered, we see big white spots nowadays.
Mm-hmm. Yeah. So I think that was all the numbers that we prepare for today. Mario, do we want to announce the winners of the T-shirt?
Yeah, I think that would be good. Let's identify with free and open source software, and for attendees who participated actively in the sessions, we have a T-shirt that we'll send them. And Hongfuk, I think you already have the list of the T-shirt winners for the first 2 days.
So I put everyone together.
You put already everyone together. Okay, that's great. So please show us the list, and I think my AI can read the list. Do you want my AI to read the list?
Yes, please go ahead.
Abha Aran Chong Aran Ho Abdul Muqtadia Endrila Das Alwan Hor Amit Gupta Anjali Kumari Ankur Ranjan and Mol Sond and Chit Poddar Anudhyan Datta Asitesh Maji Bhavesh Joshi Dong Wang Francois Kategni Guru Gurdeep Singh, Harish M. Harish Pillai, Himanshu Pandey, Ishan Sharma, Jens Peterson, Joel Chen, Kavya Sharma, Lakshmi Suresh, Leslie Wong, Mark Rodriguez, Marco Gutierrez, Mayank Mandal, Mishri Mukbal, Mubashera, Palak Nikko Kunzman, Nikhil Mahana, Nilesh Satpute, Nitish Giri, Noman Asif, Gudur Papaya, Annam Nidi, Paul Lepati, Phil Howdong, Liu Pratyush Kumar, Preeti Sharma, Priyanka Malvi, Rais Uddin Muhammad, Roland Turner, Sahil Sharma, Saket Major, Sangeeta Bain, Shagun Sharma, Shruti Pandey, Sibaditya Mitra, Sohail Gulam, Sonali Singh, Stephen Hind, Tong Tong, Tushar Jayant, Umesh Kumar Wadid, Shri Shashank Webhav Singh, Webhav Upasani, V. Satyamaz, Yangbin Ha.
Yeah, that was it. I don't know, how did you guys like it? I think it had a bit of an Indian accent.
I think it's good.
Very nice.
And this morning.
Yeah, it's very different. I improved.
Which engine?
So,
Suzy?
yeah. So again, Roland, I think we
That's Suzy AI, or is that Suzy AI?
Well, somehow it's Suzy AI, somehow not. It's very simple stuff, but yeah, it's with an Indian accent, definitely. Yeah.
I don't know, should
And
we
I
turn
said
on
the
our
name correctly? I think Roland Turner, it got it, right?
Yeah, that came out okay.
Okay, guys, so that was it. I think no more slides from your side, Homfolk, is it?
Yes, so just the end note. I don't have more slide. I just said that please stay connect with us. We are on different social media. Yes, so you can easily find us online.
Yeah, but I also would like to add, we're actually not so much a social media community. We are more of like a collaboration community. So please join our GitHub channel, join us on the GitHub projects. As you see, a lot of projects need your help. So it's not just about the projects in FOSSASIA, it's about free and open source projects all around the world. It's about policy, it's about design. There's a lot to do. We are tapping more and more into hardware, but what we need is washing machines with low energy consumption. We need like clean water. We need a lot of things that we have to solve on this planet. Be inspired by the sessions, visit other events, join with each other and collaborate. This is the message I think we try to share practically. And yeah, I would like to share it. But I would love to hear also the other team members to share their final words and their final message before we close the FOSSASIA Summit 2022. I nominate Roland first, as I see him here on the screen.
Oh God, where to start? This is the year of COVID.
Thank you. See you next year.
Likewise. Likewise. See you guys.
Thank you. See ya.
Bye-bye. Thank you.
Thank you. Bye.
Nico raising his hand.
Maybe you could say some more. All right, I will call the camera.
I will just unlock everyone. Should I unlock everyone so people
Yes,
want
please
to
do.
I
We
forgot
could
to-
unlock everyone to for or to maybe the system will not crash. I don't know that. Hopefully. So everyone, the audience will ask something. Welcome.
We leave the
the
room
channel is
open.
open now.
Yeah. So if anyone want to stay.
People
Nico,
want
you
to-
should be able to turn your camera on.
You can have a camera on.
There we go.
Yes.
Now you've got to do very complicated things to get the microphone to work. Somewhere down the bottom, you play with the speaker icon or the headphone icon or something.
Press the headphone icon 2 times.
There we go. It's happening.
Anyone else? Maybe you can turn on your camera first and then the audio.
Hello.
Success.
I hope to see everyone who has a camera to just opt in, and then we can see everybody who wants to be here. But maybe other people are too shy.
And camera back again. Hi, anyone? They want to join us? We can take a screenshot for a moment for the for the milestone moment.
Yeah, we can try. You been. I did not dare to ask people to turn on the camera. Everyone.
Actually, Spatula, you should be able to
Show
turn
your
it
hand.
on.
Raise your hand. You could. Perhaps let's take group photos. Yeah. That's
All
what we are encouraging.
All right, let me try focusing on video. Let's see how that works for us. It doesn't crash everything. Sorry if it does.
Leslie's so experienced. He knows how to do everything.